Very good morning, students. So, today we will be talking about the remaining chapters, that is Kinematics 2. So, in Kinematics 2, we have, which are the chapters anta kelidre, we are going to talk about work, power, energy, ಎರಡನೇದು ಗ್ರಾವಿಟೇಷನ್, ಮೂರನೇದು ಸಿಸ್ಟಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ and rotational motion. So these are the three chapters which we are going to have discussion in today's class. Now, coming to work, power and energy. Work, power, energy ಬಗ್ಗೆ ಹೇಳೋದಾದ್ರೆ, work done. What is the expression for work done? Work ನ ಹೇಗೆ ಕಂಡುಹಿಡಿತೀವಿ ಅಂತ ಕೇಳಿದ್ರೆ, work done by a body is given by, it is the dot product of F and S, which can be written as Fs cos theta. Fs cos theta. ಯಾವಾಗ ವರ್ಕ್ ಡನ್ 0 ಆಗುತ್ತೆ? ವರ್ಕ್ ಡನ್ ವಿಲ್ ಬಿ 0 ಫಸ್ಟ್ ಕೇಸ್ when force is 0. Second case, force is not equal to 0 but displacement is 0. ಮೂರನೇದು, ಫೋರ್ಸು 0 ಅಲ್ಲ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ 0 ಅಲ್ಲ, ಆದರೆ ಆಂಗಲ್ 90 ಡಿಗ್ರಿ ಆದರೆ ಕಾಸ್ 90 ಈಸ್ 0, ಅವಾಗಲೂ ಸಹ ವರ್ಕ್ ಡನ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಹೇಳ್ತೀವಿ. ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಅಂತ ಬಂದಾಗ ಏನಾಗುತ್ತೆ? ಇಟ್ ಈಸ್ ದ ಸಮ್ ಆಫ್ ಇಂಡಿವಿಜುವಲ್ ವರ್ಕ್ ಡನ್ಸ್ W1 plus W2 plus W3 ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. So we are going to differentiate, we are going to add the individual works in order to calculate the total work done of a system. Okay. So next, ಹಾಗಾದ್ರೆ ವರ್ಕ್ ಡನ್ ಕಂಡಿಡಿದ್ವಿ, ವೇರಿಯಬಲ್ ಫೋರ್ಸ್ ಇದ್ದಾಗ ಹೇಗಾಗತ್ತೆ ಅಂದ್ರೆ, ವರ್ಕ್ ಡನ್ ವಿಲ್ ಬಿ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಎಫ್ ಡಿ ಎಸ್ ಆಗತ್ತೆ. ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡ್ತೀನಿ ಬಿಟ್ವೀನ್ ದ ಲೋಯರ್ ಲಿಮಿಟ್ ಟು ಅಪ್ಪರ್ ಲಿಮಿಟ್. ಸೊ ವರ್ಕ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಎನರ್ಜಿ ಸ್ಪೆಂಟ್ ಆಗ್ತಿದೆ ಅಂತ ಅರ್ಥ. ವಾಟ್ ಆರ್ ದ ಟೈಪ್ಸ್ ಆಫ್ ಎನರ್ಜಿ ವಿ ಹ್ಯಾವ್ ಅಂತ ಕೇಳಿದ್ರೆ, ವಿ ಹ್ಯಾವ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಎನರ್ಜಿ. ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ, ಇದನ್ನ ಗ್ರಾವಿಟೇಷನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅಂತ ಕೇಳ್ತೀನಿ, ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು mgh. ಇನ್ನೊಂದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ, half mv square. Kinetic energy is half mv square, potential energy is m into g into h ಆಗುತ್ತೆ. So work done ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, the total amount of work done is change in kinetic energy ಅಂತ ಹೇಳ್ತೀವಿ. ಇದನ್ನ ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್ ಅಂತ ತಗೋತೀನಿ. ವರ್ಕ್ ಎನರ್ಜಿ ಥಿಯರಮ್. This is the change in kinetic energy of the bodies. ನೆಕ್ಸ್ಟ್, ಎಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಕೆಲಸ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳೋದು ಪವರ್, ವಿಚ್ ಈಸ್ ವರ್ಕ್ ಡನ್ ಬೈ ಟೈಮ್, ದಟ್ ಈಸ್ ಫೋರ್ಸ್ ಇಂಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಟೈಮ್, ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಡಾಟ್ ವಿ. ಆಫ್ ಕೋರ್ಸ್ ಇಟ್ ಇಸ್ ಅ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಫೋರ್ಸ್ ಅಂಡ್ ವೆಲಾಸಿಟಿ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್, ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ನಾವು ಕಲಿಯುವಂಥದ್ದು, ವಿ ಹ್ಯಾವ್ ಎಸ್ಪೆಷಲಿ ಏನ್ ಕ್ವಾಂಟಿಟೀಸ್ ಇದೆ ಅಂದ್ರೆ, ಎಲಾಸ್ಟಿಕ್ ಅಂಡ್ ಇನ್ಎಲಾಸ್ಟಿಕ್ ಕೊಲಿಷನ್ ಅಂತ ಬರುತ್ತೆ. ಸೊ ಎಲಾಸ್ಟಿಕ್ ಕೊಲಿಷನ್ ಈಸ್ ದಟ್ ಕೊಲಿಷನ್ that type of collision where both momentum and kinetic energy is conserved. ಮೊಮೆಂಟಮ್ಮು ಮತ್ತು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎರಡೂ ಕನ್ಸರ್ವ್ ಆದರೆ ಅದನ್ನ ಎಲಾಸ್ಟಿಕ್ ಕೊಲಿಷನ್ ಅಂತ ಕರಿತೀನಿ. Inelastic collision is a collision where you have only momentum is conserved. Momentum ಮಾತ್ರ ಕನ್ಸರ್ವ್ ಆಗುತ್ತೆ, ಬಟ್ ನಾಟ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕನ್ಸರ್ವ್ ಆಗೋದಿಲ್ಲ. There is a loss in kinetic energy during the collision. So ಇದನ್ನ ನಾನು inelastic collision ಅಂತ ಕರಿತೀನಿ. This is the synopsis regarding work power energy. Let us go to the numericals related to it. Make a note of it, please. Okay, look into the first one. A force of 20 Newton acts on a body, displaces through 5 meters along the direction inclined at 60 degrees to the direction of force. Work done ಅಂತ ಕೇಳಿದ್ದಾರೆ. ನೋಡಿ, ಹೀಗೊಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ 5 kg ಬಾಡಿ ಇಟ್ಟಿದ್ದೀನಿ. The force is applied in a particular direction. This is the direction of application of force. Body displace ಆಗೋ ಡೈರೆಕ್ಷನ್ ಹೀಗಿದೆ. So which makes an angle 60 degree ಅಂತ ಹೇಳಿದ್ದಾರೆ. Work done is F dot S. ಇಲ್ಲಿ ಯಾವ ಕಾಂಪೊನೆಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಇದನ್ನ ರಿಸಾಲ್ವ್ ಮಾಡ್ಕೋತೀನಿ. The force which is acting along the displacement direction is F cos theta ಆಗುತ್ತಲ್ವಾ. So this will be F cos theta into S ಆಗುತ್ತೆ. F goes to F cos theta. F ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 20 Newton cos 60 into 5 meter. So 100 into cos 60. Cos 60 ಎಷ್ಟು? It is half alva. Cos 60 is half, which is equal to 50 joule. The work done by this system is equal to 50 joule. Look into the second one. A body weighing 1 kg moves along a circular track of circumference of a circle of radius 0.1 meter ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Work done to complete one revolution. Work is the dot product of force and displacement. ಒಂದು ರೆವಲ್ಯೂಷನ್ ಆಗಬೇಕು ಅಂದ್ರೆ the system will come back to its initial position. ಹೌದಾ? ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್ ಬಂತು ಅಂದ್ರೆ displacement, which is a vector, is equal to 0. Therefore, work done will be equal to 0. Option A has the answer for this question. ಮೂರನೇದು ನೋಡಿ. Look into the third one. A force F equal to ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? I minus 2j plus 3k acts on a body producing a displacement of S equal to 6i plus 5k. 6i plus 5k is the displacement. ಹಾಗಾದ್ರೆ ಏನು ಕೇಳಿದ್ದಾರೆ? They have asked you to calculate the work done. So work done ಕೇಳಿದರೆ work done is nothing but the dot product of F and S. ಹೌದಾ? F dotted with S. So force I minus 2j plus 3k dotted with 6i, j ಇಲ್ಲ 0j ಅಂತ ಬರೀತೀನಿ, 5k ಬರೀಬಹುದಲ್ವಾ ಹೀಗೆ? ಹೇಗೆ ಮಾಡ್ತೀರಾ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಅಂದ್ರೆ ಮಲ್ಟಿಪ್ಲೈ ದ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ ಆಫ್ ಎಕ್ಸ್, ವೈ ಅಂಡ್ ಝೆಡ್. ಎಕ್ಸ್ ಮತ್ತೆ ವೈ ಮತ್ತೆ ಝೆಡ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದು. ಸೊ 1 into 6 ಪ್ಲಸ್ minus 2 into 0, 0 ಆಗೋಯ್ತು. 3 into 5 ಎಷ್ಟಾಯ್ತಿದು? 6 plus 15 which is equal to 21 units. ಯಾವ ಆಪ್ಷನ್ ಇದೆ? ಆಪ್ಷನ್ 2 or option B, 21 units. Fourth one, a car of 400 kg attains a speed of 50 meter per second in 20 seconds. Power developed by the engine ಅಂತ ಕೇಳಿದ್ದಾರೆ, ಹೌದಲ್ವಾ? ಪವರ್ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಪವರ್ಗೆ ಫಾರ್ಮುಲಾ ಏನು ನೋಡಿ? ಪವರ್ ಈಕ್ವಲ್ ಟು ಫೋರ್ಸ್ ಡಾಟ್ ವಿತ್ ವೆಲಾಸಿಟಿ. ಫೋರ್ಸ್ ಅನ್ನ ಹೇಗೆ ಬರೀಬಹುದು? ಎಂ ಇಂಟು ಎ ಡಾಟೆಡ್ ವಿತ್ ವಿ. ಎಂ ಹಾಗೆ ಇದೆ, ಏನ್ ಹೇಗೆ ಬರೀಬಹುದು? ವಿ ಬೈ ಟಿ ಡಾಟೆಡ್ ವಿತ್ ವಿ. ಸೊ ಪವರ್ ವಿಲ್ ಬಿ ಎಂ ವಿ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ ಟಿ ಆಗುತ್ತೆ. ಆ ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಷ್ಟು ಮಾಸು? 400 kg. ವೆಲಾಸಿಟಿ 50 meter per second, 50 into 50 divided by time is 20. 1 0 ಹೊಟ್ಟೋಯ್ತು, 2 1 times 2 20 times. 5 into 5 is 25. 25 into 2 is 50. 3 zeros ಬರುತ್ತೆ, which is equal to 50 kilowatt ಬರುತ್ತೆ. Option D is the answer for this question. Right? I'll move to the next one. Fifth one, nodi. Power required power of a pump which raises 200 kg of water. So mass is given to be 200 kg. 200 kg of water. Time ಕೊಟ್ಟಿದ್ದಾರೆ 5 seconds ಅಂತ. ಹೈಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಎಷ್ಟು? 100 ಮೀಟರ್ ಅಂತ. ವಾಟ್ ಈಸ್ ದ ಪವರ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ ನೋಡಿ. ಪವರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ವರ್ಕ್ ಡನ್ ಬೈ ಟೈಮ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ವರ್ಕ್ ಡನ್ ಬೈ ಟೈಮ್ ಈಸ್ ಪವರ್. ಇಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಅಂದ್ರೆ ಕೆಳಗಡೆ ಇರುವಂತಹ ಬಾಡಿನ ಮೇಲಕ್ಕೆ ಎತ್ತುತ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಅಲ್ವಾ? PE, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಬೈ ಟೈಮ್. ವಾಟ್ ಈಸ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ? mgh divided by time. ಮಾಸ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 400 kg ಕಾರ್. G 9.8 ಅಂತಾನೆ ತಗೊಂಡ, ಇಲ್ಲ 10 ತಗೊಂಡ್ಬಿಡೋಣ. ಹೈಟ್ 100 ಮೀಟರ್ divided by time ಎಷ್ಟು? 5 seconds. So 5 1 times, 5 twice ಹೋಯ್ತು. 4 into 2, ಹೌದಾ? mgh by t. ಸಾರಿ, 200 kg ಕೊಟ್ಟಿರೋದು, ನಾಟ್ 400. A 200 kg car. So 2 into 2 4 ಆಯ್ತು. 1 2 3 4 zeros ಆಯ್ತು, ಹೌದಾ? ಹತ್ರ ಯಾವ್ದಿದೆ ನೋಡಿ ಇದಕ್ಕೆ? 40 ಕಿಲೋವಾಟ್ ಬರಬೇಕು. 40 ಕಿಲೋವಾಟ್ಗೆ ಹತ್ರ ಇರೋದು 39.2 ಕಿಲೋವಾಟ್, ವಿಚ್ ಇಸ್ ದೇರ್ ಇನ್ ಆಪ್ಷನ್ ಸಿ. ಆಪ್ಷನ್ ಸಿ ಅಲ್ಲಿ ಇದೆ. Look into the next one. Sixth one. Momentum of a body is increased by 25%. Percentage change in kinetic energy ಕೇಳಿದ್ದಾರೆ. ಓಕೆ, ಹಾ ನೋಡಿ ಏನಾಗುತ್ತೆ. Kinetic energy is given by the formula half mv square. ನಂಗೆ ಮೊಮೆಂಟಮ್ ಬೇಕು. ಮೊಮೆಂಟಮ್ ಅಂದ್ರೆ m into v. ಆದ್ರೆ ಇನ್ನೊಂದು ವಿ ಉಳ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಐ ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಬೈ ಎಂ. ಏನಾಗುತ್ತೆ ನೋಡಿ? ಹಾಫ್ m square v square by m ಆಗುತ್ತೆ, which is equal to half p square by m ಅಂತ ಬರೀತೀನಿ. ಏಕೆಂದ್ರೆ m into v is nothing but momentum. Initial momentum ಇದು. Now momentum is increased by 25%, p dash p plus 25% of p ಎಷ್ಟಾಗುತ್ತೆ? p plus 25 by 100 of p, 25 by 100 p ಆಗುತ್ತೆ. p plus 0.25 p, ಅಲ್ಲಿಗೆ p dash equal to 1.25 p ಆಯಿತು. ನಾವು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಫಾರ್ಮುಲಾ ಏನಾಗುತ್ತೆ? k dash equal to p dash square by 2m ಆಗುತ್ತೆ ಅಲ್ವಾ? p dash square divided by 2m. ಕಂಡುಹಿಡಿಯೋಣ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ. ಸೊ p dash ಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. k dash equal to 1 by 2m ಹಾಗೆ ಇದೆ. p dash will be 1.25 p whole square. ಸೊ 1 by 2m, ಇಲ್ಲಿ p ಸ್ಕ್ವೇರ್ ಹೀಗೆ ತೆಗಿತೀನಿ ಹೊರಗೆ. 1.25 ಸ್ಕ್ವೇರ್ ಎಷ್ಟು ಅಂದ್ರೆ 1.5625 ಆಗುತ್ತೆ. ಅಲ್ಲಿಗೆ k ಡ್ಯಾಶ್ ಹೇಗೆ ಬರೀಬಹುದು ನೋಡಿ? p ಸ್ಕ್ವೇರ್ ಬೈ 2m ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ k. ಸೊ 1.5625 ಟೈಮ್ಸ್ k ಅಂತ ಹೇಳಬಹುದು. ಕರೆಕ್ಟ್. ನಾವು ಪರ್ಸೆಂಟೇಜ್ ಚೇಂಜ್ಗೆ ಫಾರ್ಮುಲಾ ನೆನ್ನೆನು ಬರೆದಿದ್ದೆ. k dash minus k by k into 100%. k dash 1.5625 minus 1 ಕಾಮನ್ ತೆಗೆಯೋಣ k ನ, divided by k into 100%. k cancel ಆಯಿತು. you will be having 0.5625 into 100%, which is equal to 56.25% ಆಗುತ್ತೆ. ಆನ್ಸರ್ is there as 56. Option C is the answer. ನೋಡಿ, this is one of the important question with respect to your CET. So please make a note of it. Okay, now let us go to the next one. Seventh one nodi. Seventh one, two bodies of masses m1 and m2 have equal momenta. Momenta same ಇದೆ. ಕೈನೆಟಿಕ್ ಎನರ್ಜೀಸ್ ನ E1 E2 ಅಂತ ಹೇಳಿದ್ರೆ E1 by E2 ಈಗಿನ್ನು ಮಾಡಿದ್ವಿ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿನ ಇಲ್ಲಿ E ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, p square by 2m. ಸೊ E1 will be p square by 2m1, E2 will be p square by 2m2. E1 by E2 p same ಇದೆ, E1 by E2 will be p square by 2m1 divided by p square by 2m2. ನೋಡಿ, p square by 2 p square by 2 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, m2 ಮೇಲಕ್ಕೆ ಹೋಗುತ್ತೆ, which is m2 divided by m1. ಆಪ್ಷನ್ ಡಿ ಅಲ್ಲಿ ಆನ್ಸರ್ ಇದೆ. Right, look into the next one. Eighth one. A body weighing 40 kg should fall from dash height so as to have the same kinetic energy as that of 196 kg truck traveling at 12 meter per second ಅಂತ ಹೇಳಿದ್ದಾರೆ. ನೋಡಿ, ಯಾವ ಹೈಟ್ ಇಂದ ಬೀಳ್ತಾ ಇದೆ ಅಂದ್ರೆ ಎಂತ ಎನರ್ಜಿ ಇದೆ? ಕೈನೆಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಮೂವ್ ಆಗ್ತಿದೆ ಟ್ರಕ್ಕು ಅಂತ ಹೇಳಿದ್ರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಸೊ ಯಾವ ಹೈಟ್ ಇಂದ ಬಿದ್ರೆ ಎಂ ಜಿ ಹೆಚ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್. ಯಾಕಂದ್ರೆ ಈ ಬಾಡಿಯ ಮಾಸೆ ಬೇರೆ, ಮೂವ್ ಆಗ್ತಾ ಇರುವಂತ ಬಾಡಿಯ ಮಾಸೆ ಬೇರೆ. ಸೊ ಫ್ರಮ್ ವಾಟ್ ಹೈಟ್ ಎ 40 kg ಬಾಡಿ ಅಂತ ಹೇಳಿದರೆ, ಸೊ 40 kg ಜಿ 10 ತಗೊಳ್ಳೋಣ ಇಂಟು ಹೆಚ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್. ಓಕೆ, ಜಿ ನ 9.8 ತಗೊಳ್ಳೋಣ, ಯಾಕೆಂದ್ರೆ ಸಾಲ್ವ್ ಮಾಡುವಾಗ ಸುಲಭ ಆಗುತ್ತೆ. 9.8 ಹೆಚ್ ಈಕ್ವಲ್ ಟು ಹಾಫ್ ಎಂ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 196 kg ಟ್ರಕ್. ಫೈನ್, ಮೂವಿಂಗ್ ಎಟ್ 12 meter per second. ಸೊ 12 ಸ್ಕ್ವೇರ್ ಆಯ್ತು. ಕರೆಕ್ಟ್. ನೋಡಿ ಇಲ್ಲಿ 9.8 1 times 9.8 2 times 20 times is 19.6. ಈಸಿಯಾಗಿ ಹೊಟ್ಟೋಗುತ್ತೆ. 21 times 22 times. ಅಲ್ಲಿಗೆ ಹೆಚ್ ಈಕ್ವಲ್ ಟು 12 into 12 divided by 4 ಆಯ್ತು. ಹೌದಾ? 2 into 2 4 ಆಯ್ತು. 4 1 times 4 thrice. ಸೊ ಹೆಚ್ ಈಕ್ವಲ್ ಟು ಎಷ್ಟಾಯ್ತು? 36 meter. Option B is the answer. So if a body falls from a height of 36 meter, then the energy attained by that body will be equal to 196 kg truck moving at 12 meter per second ಗೆ ಸಮ ಆಗುತ್ತೆ ಅಂತ ಅದರ ಅರ್ಥ. Ninth one, a ball dropped from a height h1 ಕೊಟ್ಟಿದ್ದಾರೆ. h1 ಎಷ್ಟು? 20 meter. Rebounds to a height of 10 meter. h2 ಎಷ್ಟು? 10 meter. Then the loss in energy. ಎಂತ ಎನರ್ಜಿ ಲಾಸ್ ಆಗ್ತಾ ಇದೆ? ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ U1 ಈಕ್ವಲ್ ಟು mgh1. U2 will be equal to mgh2. Loss in energy, so delta U will be U1 minus U2. Again, initial energy will be more than final energy. mgh1 minus mgh2 ಆಯ್ತು. ಸೊ mg ಕಾಮನ್ ತೆಗೆದ್ರೆ h1 minus h2 ಆಯ್ತು. ಸೊ mg ಎಷ್ಟಾಯ್ತು ನೋಡಿ? h1 minus h2 20 minus 10 which is equal to 10 times mg ಆಯ್ತು. ಹೌದಾ? ಫಸ್ಟ್ ಎಷ್ಟಿತ್ತು? 20. ಈಗ ಎಷ್ಟು ಬಂತು? 10. ಸೊ ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಕಮ್ಮಿ ಆಯ್ತು? ಇಟ್ ಈಸ್ 50% ಕಮ್ಮಿ ಆಯ್ತಲ್ವಾ? ಹೆಂಗ್ ಮಾಡೋದನ್ನ? ಲಾಸ್ ಇನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ನೋಡಿ, ಡೆಲ್ಟಾ ಯು ಬೈ ಯು ಮಾಡ್ತೀನಿ. 10 mg divided by delta u1 is 20 mg. mg cancel ಆಯ್ತು. You have half which is equal to 50%. Of course, ಹೆಂಗ್ ಬಂತು 50% ಅಂದ್ರೆ into 100% ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಆಪ್ಷನ್ ಸಿ has the answer for this question. Look into the 10th one. A body weighing 1 kg is thrown up at a certain height. ಯಾವುದೋ ಒಂದು ಹೈಟ್ ಅಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಎಷ್ಟಿದೆಯಂತೆ? 800 ಜೌಲ್. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎಷ್ಟಿದೆಯಂತೆ? 180 ಜೌಲ್. Then it can reach a maximum height. ನೋಡಿ, ಫಸ್ಟ್ ಟೋಟಲ್ ಎನರ್ಜಿ ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋಣ. Total energy is sum of potential and kinetic, which is equal to 800 plus 180, which is equal to 980 joule is the total energy. ಯಾವುದೋ ಒಂದು ಹೈಟ್ ಅಲ್ಲಿ. ಓಕೆ, now it reaches the maximum height. maximum height reach ಆಯ್ತು ಅಂದ್ರೆ ಎಂಥ ಎನರ್ಜಿ ಇರುತ್ತೆ ನೋಡಿ. at maximum height ಅದಕ್ಕೆ ಟೋಟಲ್ ಎನರ್ಜಿ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು, ಬರೀ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ 0 ಆಗುತ್ತೆ, ಬರೀ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಮಾತ್ರ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಇ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು? mgh equation 2 ಅಂತ ಕರ್ಕೋತೀನಿ. ಇದು equation 1. ಈಕ್ವೇಟ್ ಮಾಡಿದ್ರಾಯ್ತು 1 and 2 ನ mgh equal to 980, h equal to ಬಾಡಿ ಎಷ್ಟು ಕೆಜಿ ಕೊಟ್ಟಿದ್ದಾರೆ 1 kg. ಸೊ 980 divided by 9.8 ಆಯ್ತು. ಸೊ h will be equal to 100 meter. Option D has the answer. Correct. Look at the next one. I'll go to the 11th one. 11th one. A body of mass 2 kg is thrown upward such that the kinetic energy is 490 joule. The height at which kinetic energy becomes half. So, ಯಾವ height ಅಲ್ಲಿ ಅಂತ ಕೇಳಿದ್ರೆ kinetic energy becomes half. ಯಾವ height? So, total energy will be kinetic energy by 2. Height ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ ಬರೀ potential energy ಇರುತ್ತೆ mgh ಅಲ್ಲಿ. Correct? mgh equal to 490 divided by 2. Okay. ಏನಾಯ್ತಿದ್ದು h ಕಂಡುಹಿಡಿಬೇಕು. h equal to 490 divided by 2 into m into g, which is equal to 490 divided by 2 into mass ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 2 kg, g is 9.8. Correct. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಆಯ್ತು 10 ಅಂತ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ 10 ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಇದು ಹೋಗುತ್ತೆ 50/4 12.5 ಮೀಟರ್ ಬರುತ್ತೆ, ವಿಚ್ ಇಸ್ ದೇರ್ ಇನ್ ಆಪ್ಷನ್ ಬಿ ಅಲ್ಲಿ ಇದೆ. Twelfth one. A body slides down. From rest ಅಂತ ಹೇಳಿರೋದ್ರಿಂದ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ 0 ಆಗೋಗುತ್ತೆ. Slides down from rest into a frictionless track with a quadrant of a circle of radius ಕೇಳಿದ್ದಾರೆ. ಸೊ ರೇಡಿಯಸ್ 5 ಮೀಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸ್ಪೀಡ್ ಎಟ್ ದ ಬಾಟಮ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಸ್ಪೀಡ್ ಎಟ್ ದ ಬಾಟಮ್ ಇಸ್ ಗಿವನ್ ಬೈ vertical circle is given by root of 5 into r into g. Vertical circle root 5rg. Horizontal circle root 3rg ಆಗುತ್ತೆ. ಓಕೆ. ಸೊ ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್ ಇರೋದ್ರಿಂದ ರೂಟ್ 5rg ಆಗುತ್ತೆ. ಸೊ ವೆಲಾಸಿಟಿ ವಿಲ್ ಬಿ 5 ಇಂಟು ರೇಡಿಯಸ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ. ರೇಡಿಯಸ್ ಇಸ್ ಗಿವನ್ ಟು ಬಿ 5 ಮೀಟರ್ ಇಂಟು ಇದನ್ನ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ 9.8 ಆಫ್ ಕೋರ್ಸ್. ಓಕೆ, ಇಲ್ಲಿ ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್ ಹಾರಿಜಾಂಟಲ್ ಸರ್ಕಲ್ ಅಂತ ಏನು ಕೊಟ್ಟಿಲ್ಲ. ಸೊ ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಡೂ ಇಸ್ ದಿಸ್ ಸಿಂಪಲ್. ಸೊ ವೆಲಾಸಿಟಿ ಆಫ್ ಎ ಬಾಡಿ v ಸ್ಕ್ವೇರ್ ಈಕ್ವಲ್ ಟು u ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2as ಉಪಯೋಗಿಸೋಣ. ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ 0, ಸೊ 2gh ಆಗುತ್ತೆ. ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಿದ್ರೆ ಐ ವುಡ್ ಹ್ಯಾವ್ ಗಾನ್ ವಿತ್ ಇದನ್ನು 5rg ಹೋಗ್ತಾ ಇದ್ದೆ. ಏನು ಕೊಟ್ಟಿಲ್ಲದೆ ಇರೋದ್ರಿಂದ ಇಟ್ ಈಸ್ 2rg ಆಗುತ್ತೆ. ಸಾರಿ 2gh. ಸೊ 2 into g is 9.8, h is nothing but radius which is equal to 5 meter ಆಯ್ತು. ಸೊ ಇದಿಷ್ಟನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ, ರೂಟ್ 98 ಬರುತ್ತೆ. ರೂಟ್ 98 I have it in option B. Correct. Thirteenth one. ನೋಡಿ. A body of mass 9 kg. A body of mass 9 kg explodes into two pieces whose masses in the ratio 1:2. Nodi m1 is to m2 equal to 1:2. Andre 1 by 2. m1 by m2 equal to half. So m2 equal to 2m1. Okay. So ಅಲ್ಲಿಗೆ ಏನಾಯ್ತು ಟೋಟಲ್ ಮಾಸ್ ಏನಾಗುತ್ತೆ ನೋಡಿ m1 ಪ್ಲಸ್ m2 ಈಕ್ವಲ್ ಟು 9. m2 ಈಕ್ವಲ್ ಟು 2m1 ಆದ್ರೆ 2m1 ಈಕ್ವಲ್ ಟು 9. 3m1 ಈಕ್ವಲ್ ಟು 9. m1 ಈಕ್ವಲ್ ಟು 3 kg ಆದ್ರೆ m2 ಎಷ್ಟಾಯ್ತು 6 kg ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಟೋಟಲ್ ವಿಲ್ ಬಿ 3 ಪ್ಲಸ್ 2 3 ಪ್ಲಸ್ 6 9 ಆಯ್ತು. ಹೌದಾ? ನೆಕ್ಸ್ಟ್ ಇನ್ನೇನು ಹೇಳ್ತಾರೆ ನೋಡಿ, ಎಕ್ಸ್ಪ್ಲೋಡ್ಸ್ ಇಂಟು ಟೂ ಪೀಸಸ್ ರೇಷಿಯೋ ಆಯ್ತು. ಲೈಟರ್ ಮಾಸ್ ವಿಲ್ ಮೂವ್ ವಿತ್ ವೆಲಾಸಿಟಿ 16 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಸೊ v1 16 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಆದ್ರೆ ವಾಟ್ ಈಸ್ ದ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಆಫ್ ದ ಸೆಕೆಂಡ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ ಅಲ್ವಾ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ವೆಲಾಸಿಟಿ ಬೇಕಲ್ವಾ ಇದ್ರದ್ದು. ಹೇಗೆ ಕಂಡುಹಿಡಿತೀರಾ? ಫ್ರಮ್ ದ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೊಮೆಂಟಮ್. ಫಸ್ಟ್ v2 ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋಣ. ಸೊ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ಮಾಡೋಣಂತೆ. ಏನ್ ಹೇಳುತ್ತೆ, ಇನಿಷಿಯಲಿ ರೆಸ್ಟ್ ಅಂತ ಹೇಳಿದ್ರೆ m1 v1 ಈಕ್ವಲ್ ಟು m2 v2 ಆಗುತ್ತೆ. m1 3 kg into 16 equal to 6 kg into v2. So 3 1 times 3 twice. ಇಲ್ಲೇ v2 ಸಿಕ್ಬಿಡುತ್ತೆ. v2 ಈಕ್ವಲ್ ಟು 8 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಹೌದಾ? ಸೊ v2 8 ಸಿಕ್ಕ ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀರಾ? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ k2 is equal to half m2 v2 square ಅಲ್ವಾ. ಸೊ half m2 is 6 kg, v2 is 8 square. ಇದು 3 times ಹೋಗುತ್ತೆ. 3 into 64, 8 square is 64. So 3 into 64 ಏನಾಯ್ತು? It is 192 joule. Option B is the answer. Right? I'll move on to the next one. Hope you have completed this. Look into the 14th one. Important to 14th one. A body of mass 4m at rest explodes into two pieces whose masses are in the two of the pieces move each other of mass m with speed v in perpendicular direction. The total kinetic energy ಕೇಳಿದ್ದಾರೆ ನೋಡಿ. ಇದೊಂಚೂರು ನಿಧಾನಕ್ಕೆ ನೋಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ 4m ಮಾಸ್ ಇದೆ. This explodes into two pieces. ಅದರಲ್ಲಿ ಒಂದು ಇಟ್ ಮೂವ್ ಆಫ್ ಮಾಸ್ m with velocity v. ಇನ್ನೊಂದು ಮಾಸ್ m with velocity v mutually perpendicular direction ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಉಳಿದಿರೋ ಮಾಸ್ ಎಷ್ಟು? 4m ಅಲ್ಲಿ m ಹೊಟ್ಟೋದ್ರೆ ಉಳಿದಿರೋದೇ 2m. So 2m has to travel in this direction. Conservation of momentum ಆಗಬೇಕು ಅಂದ್ರೆ ಕ್ಯಾಪಿಟಲ್ V ತಗೋತೀನಿ. They are perpendicular to each other ಅಂತ ಹೇಳಿದ್ದಾರೆ. So I need to resolve them along x-axis. Horizontal, ಇನ್ನೊಂದು ವರ್ಟಿಕಲ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಾನು ರಿಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಯಾಕೆಂದ್ರೆ ನಾನು ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಥವಾ ಈಕ್ವೇಟ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಐ ನೀಡ್ ಟು ಹ್ಯಾವ್ ಎ ಡೈರೆಕ್ಷನ್. ನೋಡಿ ಇದೆಷ್ಟಾಗುತ್ತೆ? 45 ಡಿಗ್ರಿ ಆಗುತ್ತೆ. Horizontal component will be mv cos 45. vertical component will be mv sin 45. ಇದು ಈ ಬಾಡಿದಾಯ್ತು ಫಸ್ಟ್ ಬಾಡಿ. ಅದೇ ತರ ಸೆಕೆಂಡ್ ಬಾಡಿದು ಹಾರಿಜಾಂಟಲ್ ಕಾಂಪೊನೆಂಟ್ ವಿಲ್ ಬಿ mv cos 45, vertical component will be mv sin 45. ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ಹಾಕ್ತೀನಿ. ಫ್ರಮ್ ದ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ನಿಧಾನಕ್ಕೆ ನೋಡ್ಕೊಳ್ಳಿ, ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಬ್ಲಮ್. ಅವ್ರು ಕೇಳಿರೋದು ಟೋಟಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕೇಳಿದ್ದಾರೆ. ಟೋಟಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕಂಡುಹಿಡಿಬೇಕು ಅಂದ್ರೆ ನನಗೆ ಈ ಕ್ಯಾಪಿಟಲ್ ವಿ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಸ್ಮಾಲ್ ವಿ ಬೇಕು. ಸೊ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮೊಮೆಂಟಮ್ ಅನ್ನು ಹಾಕಿದ್ರೆ 2m ಇಂಟು ಕ್ಯಾಪಿಟಲ್ ವಿ ಈಕ್ವಲ್ ಟು mv cos 45 ಪ್ಲಸ್ mv cos 45 ಆಗುತ್ತೆ. ಯಾಕೆ sin 45 ಏನಾಯ್ತು ಅಂತ ಕೇಳಿದ್ರೆ, ಸಿನ್ಸ್ ದೇ ಆರ್ ಆಪೋಸಿಟ್ ಟು ಈಚ್ ಅದರ್ ದೇ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ಡ್ ಆಫ್, ಕ್ಯಾನ್ಸಲ್ ಆಗೋಗುತ್ತೆ ಅಲ್ವಾ. ನೋಡಿ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್, ಇಲ್ಲಿ ಮೇಲೆ ಇದು ಹೋಗ್ತಾ ಇದ್ರೆ ಇದು ಕೆಳಗೆ ಬರ್ತಾ ಇರುತ್ತೆ. ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್, ಆಪೋಸಿಟ್ ಇನ್ ಡೈರೆಕ್ಷನ್, ದೇ ವಿಲ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ಡ್ ಆಫ್. ನೌ 2mv equal to capital V equal to 2m small v into cos 45. 2m cancel ಆಯಿತು. ಸೊ ಕ್ಯಾಪಿಟಲ್ ವಿ ಈಕ್ವಲ್ ಟು ವಿ ಬೈ ರೂಟ್ 2, ಯಾಕೆಂದ್ರೆ ಕಾಸ್ 45 ಈಸ್ ವಿ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ 2 ಅಲ್ವಾ. ನಾವು ನೆಕ್ಸ್ಟ್ ಏನ್ ಕೇಳಿದಾರೆ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ದ ಸಮ್ ಆಫ್ ದೇರ್ ಇನಿಷಿಯಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜೀಸ್ k1 k2 k3 ಆಗುತ್ತೆ. k1 half mv square, k2 half mv square, k3 half mass is 2m capital V square. ನೋಡಿ ಇದೇನಾಯ್ತು, ಹಾಫ್ mv square plus half mv square is mv square ಆಯ್ತು. ಇಲ್ಲಿ 2 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. m what is capital V? V by root 2 whole square. So it is mv square plus mv square by 2. So kinetic energy will be 3 by 2 mv square. ಆಪ್ಷನ್ ಎ ಅಲ್ಲಿದೆ. ನಿಧಾನಕ್ಕೆ ನೋಡ್ಕೊಳ್ಳಿ, ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಬ್ಲಮ್ ಇದು. Okay, so I will resolve the components into corresponding directions. ಇದು ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟರು ಈ ತರ ಆಂಗಲ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ surely you need to follow the same procedure. Next one, fifteenth one. A pendulum bob of mass m is held in horizontal position and released. Horizontal position ಅಂದ್ರೆ ಹೀಗೆ ಇಟ್ಕೊಂಡು ರಿಲೀಸ್ ಮಾಡಿದ್ದಾರೆ. It is going to execute, ಇದು ಕೆಳಗೆ ಬರಕ್ಕೆ ಶುರುವಾಗುತ್ತೆ. When it reaches the lowest position ಅಂದ್ರೆ ಹಿಂಗಲ್ವಾ, ಈ ಪೊಸಿಷನ್ ಗೆ ಬಂದಾಗ what is the tension in the string? Tension will be always directed upward. ಇಲ್ಲಿ weight will be only one which will be always directed downward. So tension will be equal to m into g. Option C is the answer. Right, next ನೋಡಿ 16th problem ಇಂದ we are going to talk about gravitation. ಗ್ರಾವಿಟೇಷನ್ ಅಲ್ಲಿ ಬರೋದು ಫಸ್ಟ್ ಯೂನಿವರ್ಸಲ್ ಲಾ ಆಫ್ ಗ್ರಾವಿಟೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ, ವೇರ್ ಎಫ್ ಈಕ್ವಲ್ ಟು G m1 m2 divided by r square, where capital G is known as universal gravitational constant 6.67 into 10 power minus 11 Newton meter square per kg square will be the value of it. But the gravity on the earth, it will be Gm divided by r square, where m is the mass of the earth, r is the radius of the earth agate, and the value we know it is 9.8 meter per second square. But is the value G same if you go above the earth surface or if you go below the earth surface anta kelidre, at a height h, at a height h above the earth surface igadre, the formula will be G dash equal to G into 1 minus 2h by r. Next, at a depth d, at a depth d below the surface ಗೆ formula ತಗೊಂಡ್ರೆ G dash equal to G into 1 minus d divided by r ಆಗತ್ತೆ. Okay, Ade, if you go from equator towards the pole, so variation of G with respect to latitude anta karitini. Latitude andre if you go from poles in the equator ge ಅಥವಾ equator in the pole kadeke hodre, the formula will be G dash equal to G minus omega square r cos square theta. So ಈ ಕೇಸ್ ನೋಡಿ, on equator ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, theta will be equal to 0 degree. Therefore G dash equal to G minus omega square r ಆಗುತ್ತೆ. Poles ಅಲ್ಲಿ, at the poles, theta will be equal to 90 degree. So G dash will be equal to G ಆಗುತ್ತೆ. Maximum at the poles, minimum at the equator. Poles ನಲ್ಲಿ maximum ಇರುತ್ತೆ, equator ಅಲ್ಲಿ minimum ಇರುತ್ತೆ. Okay. Now Kepler's laws of planetary motion anta barutte. We have 3 laws. Adralli major agi ಬೇಕಾಗಿರುವಂತದ್ದು t square proportional to r cube, which is called as law of time period. The square of time period of revolution of a planet around the sun is proportional to cube of the average distance between the sun and the earth anta ಹೇಳ್ತೀವಿ. Now if I proceed further, escape velocity anta barutte. It is given by root of 2gr. Orbital velocity anta barutte, root of gr. So I can say escape velocity is root 2 times orbital velocity. Bekadashtu tharada satellites ಗಳಿವೆ. We have like a geostationary satellite, weather forecasting satellite, ಡಿಫೆನ್ಸ್ ಸ್ಯಾಟಲೈಟ್ಸ್ ಅಂತಿದೆ, ಆಮೇಲೆ ಕಮ್ಯುನಿಕೇಶನ್ ಸ್ಯಾಟಲೈಟ್ಸ್, ಇದೆಲ್ಲದಕ್ಕೂ ವಿ ವಿಲ್ ಯೂಸ್ ದ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಕರೆಸ್ಪಾಂಡಿಂಗ್ಲಿ. ಓಕೆ, right. If there is a case, we'll move to the numericals. 16th one. Acceleration due to gravity at the equator. Iginu explain madde. It is minimum but not zero. So minimum ide adre zero illa. Okay, just now we saw it. 17th one. Nodi. The period of oscillation of the simple pendulum at the center of earth. What is the expression for time period of simple pendulum? It is given by 2 pi root L by G. Alva, 2 pi root L by G. So at the center of the earth ಅಲ್ಲಿ G ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ರೆ, center of the earth the value of G equal to 0. Value of G 0 ಅಂದ್ರೆ time period ಏನಾಯ್ತು infinity ಆಯ್ತು ಯಾಕೆಂದ್ರೆ 1/0 will be infinity. So minimum but not 0, maximum does not oscillate at all, same as it of the surface of the earth. Infinity ಬರ್ತಾ ಇರೋದ್ರಿಂದ it feels to me that it is not at all oscillating, ತುಂಬಾ ಸ್ಲೋ ಆಗಿ oscillate ಆಗುತ್ತೆ. So I feel that it is not at all oscillating. So it does not oscillate at all. Oscillate ಆಗಲ್ಲ ಅಂತ ಅನ್ಸುತ್ತೆ. Option B is the answer. Sorry, option D is the answer. Look into the next one. 18th one. G is the acceleration due to gravity on the Earth's surface. G dash at a height h equal to 32 kilometer above the Earth's surface. Radius of Earth ಕೊಟ್ಟಿದ್ದಾರೆ r equal to 6400 kilometer ಅಂತ. ಹಾಗಾದ್ರೆ what is the value of G dash ಅಂತ ಕೇಳಿದ್ದಾರೆ. With respect to height ಹೇಳಿರೋದ್ರಿಂದ ಫಾರ್ಮುಲಾ ಯಾವುದಾಗುತ್ತೆ, G dash equal to G into 1 minus 2h divided by r. Correct alva? So G dash equal to G into 1 minus 2 into 32 divided by 6400. ಏನಾಗುತ್ತೆ ನೋಡಿ, G into 1 minus 64 by 6400 ಆಗುತ್ತೆ. 64 1 times, 6400 times. G into 1 minus 1 by 100. So LCM ತೆಗೆದ್ರೆ 100 minus 1 divided by 100 ಆಗುತ್ತೆ, which is 99 by 100 times G, or G dash equal to 0.99 times actual value. ಅಷ್ಟೇ. So option B has the answer for this question. Is it fine? Next one ನೋಡಿ, 19th one. Acceleration due to gravity is reduced to 1/3 of the value at a depth dash below the surface of the earth ಅಂತ ಕೇಳಿದ್ದಾರೆ. Acceleration due to gravity G dash reduced to 1/3 ಅಂದ್ರೆ G by 3, 1/3 of the value on the surface of the earth. So G dash is equal to G by 3 ಆಯ್ತು. ಯಾವ ಡೆಪ್ತ್ ಅಲ್ಲಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. At what depth you are going to have this ಅಂತ ಕೇಳಿರೋದು. ಫಾರ್ಮುಲಾ ಏನಾಗುತ್ತೆ, G dash equal to G into 1 minus D divided by R. G dash value ಕೊಟ್ಟಿದ್ದಾರೆ G by 3 equal to G into 1 minus D divided by R. G cancel ಆಯ್ತು. 1 by 3 equal to 1 minus D by R. So D by R equal to 1 minus 1 by 3, which is equal to 2 by 3 ಆಯ್ತು D by R. So D ಎಷ್ಟಾಯ್ತು, 2 by 3R, which is there in option B. Twentieth Mass of the earth increases by 10%, acceleration due to gravity becomes, mass of the earth 10% ಜಾಸ್ತಿ ಆಯಿತು ಅಂದರೆ m dash equal to m plus 10% of m. ಎಷ್ಟಾಯ್ತು ಅಲ್ಲಿಗೆ? m plus 10 by 100 of m. ಇಲ್ಲಿಗೆ m plus 0.1 m ಆಯಿತು. ಸೊ m dash is equal to 1.1 m ಆಯಿತು. ನನಗೆ ಫಾರ್ಮುಲಾ, ಜನರಲ್ ಫಾರ್ಮುಲಾ ಏನು? g equal to gm by r square. ಇದಕ್ಕೆ g dash ಅಂತ ಕರ್ಕೋತೀನಿ, g m dash divided by r square. ಸೊ g by r square ಹಾಗೆ ಇದೆ. m dash is 1.1 m. ಏನಾಗುತ್ತೆ ನೋಡಿ, ಇದು 1.1 into gm by r square ಅಂತ ಬರಿಬಹುದು. ಸೊ g dash equal to 1.1 times g, because gm by r square is nothing but g. 1.1 times g ಆಗುತ್ತೆ. ಆಪ್ಷನ್ A is the answer for it. Next one, ಇಲ್ಲೇ ಮಾಡೋಣ. 21st. If earth spins faster, fast ಆಗಿ ಸ್ಪಿನ್ ಆದರೆ ಅರ್ಥ, acceleration due to gravity at the poles decreases, increases, remains the same, becomes zero. It remains the same. ಯಾಕೆಂದ್ರೆ ಪೋಲ್ಸ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ. ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಎಟ್ ದ ಈಕ್ವೇಟರ್ ಅಂತ ಕೇಳಿದ್ರೆ, ಈಕ್ವೇಟರ್ ಅಲ್ಲಿ ಏನಾಗಬಹುದು ಅಂತ ಕೇಳಿದ್ರೆ ನೋಡಿ, ಜಿ ಡ್ಯಾಶ್ ಫಾರ್ಮುಲಾ ಏನು? ಜಿ ಮೈನಸ್ ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಆರ್ ಈಕ್ವೇಟರ್ ಅಲ್ಲಿ. ಸೊ ಒಮೆಗಾ ಜಾಸ್ತಿ ಆದರೆ ಜಿ ಡ್ಯಾಶ್ ವಿಲ್ ಬಿ ಲೆಸ್ ದ್ಯಾನ್ ಜಿ. ಸೊ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಗ್ರಾವಿಟಿ ಡಿಕ್ರೀಸಸ್ ಇಫ್ ಇಟ್ ಸ್ಪಿನ್ಸ್ ಫಾಸ್ಟರ್. Decreases at equator. Equator ಅಲ್ಲಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ if it spins faster. Next one, 22nd. Acceleration due to gravity on a planet whose radius and density twice as that of Earth. Radius on the planet is twice the radius of Earth. Density on the planet is twice the density on Earth. If g is the acceleration due to gravity of Earth, then g dash ಗೆ g ಗೂ ಏನು ಸಂಬಂಧ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಫಾರ್ಮುಲಾ ಏನು? ಫಸ್ಟ್ ಡಿರೈವ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. g equal to gm divided by r square. g by r square ಹಾಗೆ ಬರೀತೀನಿ. ಮಾಸ್ ಕೊಟ್ಟಿಲ್ಲ ನಂಗೆ, ಮಾಸ್ ಬದಲು ದೇ ಹ್ಯಾವ್ ರಿಟರ್ನ್ ಇಟ್ ಇನ್ ದ ಡೆನ್ಸಿಟಿ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಹೌ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಮಾಸ್? ಮಾಸ್ ಅನ್ನ ನಾನು ಡೆನ್ಸಿಟಿ ಇಂಟು ವಾಲ್ಯೂಮ್ ಅಂತ ಬರೀಬಹುದಲ್ವಾ? ಸೊ ಜನರಲ್ ಈಕ್ವೇಶನ್ g by r square into rho. ರೋ ಹಾಗೆ ಇದೆ. ವಾಟ್ ಈಸ್ ದಿಸ್ ವಾಲ್ಯೂಮ್? ವಾಟ್ ಈಸ್ ದ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಸ್ಪಿಯರ್? ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಸ್ಪಿಯರ್ ಅಂತ ತಗೋತೀನಿ. ಯಾಕೆ ಸ್ಪಿಯರ್? ಅರ್ತ್ ನ ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಅಲ್ಲಿ ಇದೆ. We take it as, so 4 by 3 pi r cube ಅಂತ ಬರೀತೀನಿ. r square r cube ಒಂದು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ಸೊ g equal to 4 by 3 pi rho g r. ಇಲ್ಲಿ ಎರಡು ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದು. ಯಾವುದು? ಡೆನ್ಸಿಟಿ ಮತ್ತು ರೇಡಿಯಸ್ ಮಾತ್ರ ಚೇಂಜ್ ಆಗ್ತಿರೋದು. ಸೊ ಐ ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ g ಪ್ರಪೋರ್ಷನಲ್ ಟು ರೋ ಇಂಟು r ಅಂತ ಹೇಳ್ಬಹುದಲ್ವಾ? Yes. ಸೊ ಜಿ ಡ್ಯಾಶ್ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಏನಾಗುತ್ತೆ? ಯಾವುದೋ ಪ್ಲಾನೆಟ್ ರೋ ಪಿ ಆರ್ ಪಿ ಆಗುತ್ತೆ. ಸೊ ಜಿ ಡ್ಯಾಶ್ ಬೈ ಜಿ ಮಾಡಿದ್ರೆ ಇಟ್ ಈಸ್ ರೋ ಡೆನ್ಸಿಟಿ ಆಫ್ ಪ್ಲಾನೆಟ್ ಇಂಟು ರೇಡಿಯಸ್ ಆಫ್ ಪ್ಲಾನೆಟ್ ಬೈ ಡೆನ್ಸಿಟಿ ಆಫ್ ಅರ್ತ್ ಇಂಟು ರೇಡಿಯಸ್ ಆಫ್ ಅರ್ತ್ ಆಯ್ತು. ಕರೆಕ್ಟ್? ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು ನೋಡಿ, Density of planet is 2 times the density of Earth. So, ಇಲ್ಲಿ density of Earth. Radius of planet is also 2 times the radius of Earth. 2 RE by RE. RE cancel ಆಯಿತು. So, G dash by G equal to 4 ಆಯಿತು. So, therefore, G dash equal to 4 times G. We have it in option B. Right? Okay, look into the next one. 23. If the distance between the Earth and Sun were reduced to 1/4 of the present distance, R dash equal to R by 4, 1/4 of the present distance, then the duration of the year would be, duration of the year ಏನಾಗ್ತಾ ಇತ್ತು ಅಂತ ಕೇಳಿದ್ದಾರೆ. I'll be using the formula ಯಾವುದು, T square proportional to R cube. So, T1 by T2 whole square equal to R1 by R2 whole cube. Correct? ಇಲ್ಲಿ R1 equal R2 equal to R1 by 4 ಅಂತ ಕರ್ಕೊಳ್ಳೋಣ. T1 ನೋಡಿ, ಅರ್ಥಿನ ರೇಡಿಯಸ್ ಡಿಸ್ಟೆನ್ಸ್ R ಇದ್ದಿದ್ದಾಗ the value was 1 year. 1 by T2 whole to the power 2 equal to R1 ಹಾಗೆ ಇದೆ, R2 ಏನಾಗುತ್ತೆ, R1 by 4 whole cube. ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗಿ you will get 4 cube ಬರುತ್ತೆ. ಹೌದಾ? 1 by 4 ಇದ್ದಿದ್ದು ಮೇಲಕ್ಕೆ ಹೋದಾಗ 4 cube ಆಯ್ತು. Yes. So, the value ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ. He'll be having 1 by T2 square equal to 64. So, 1 by T2 will be equal to root 64, 8 ಆಯಿತು. So, T2 will be equal to 1 by 8th of an year. So, 1 by 8th option ಇದೆಯಾ? Yes, option C ಅಲ್ಲಿ ಇದೆ, 1 by 8th of an year. Correct? All right, we'll go to the next one. ಮುಂದೆ ಇರೋ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಸಿಸ್ಟಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮತ್ತು ರೊಟೇಷನಲ್ ಮೋಷನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸೊ ಸಿಸ್ಟಮ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ನಾವು ಮಾತಾಡೋದೆ ಆಂಗ್ಯುಲರ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತೀವಿ. ಸೊ ಆಂಗ್ಯುಲರ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್, ಹೇಗೆ ಆಂಗ್ಯುಲರ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ನ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ S equal to R into theta, V equal to R into omega. This is the relation connecting between linear ಮತ್ತು angular parameters ಗೆ. A equal to R into alpha, where theta ಅಂದ್ರೆ ಏನು, linear angular displacement given by 2n pi. Omega equal to theta by t. Alpha equal to omega by t ಆಗುತ್ತೆ. These are all instantaneous values. Okay na? More equations ಇದೆ which governs the variation of the particle given by omega equal to omega naught plus alpha t. Theta equal to omega naught t plus half alpha t square. Omega square equal to omega naught square plus 2 alpha theta. ನಾವು kinematics ಅಲ್ಲಿ ಬರ್ದಿದ್ವಲ್ವಾ, ಸೇಮ್ ಈಕ್ವೇಶನ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ತೀನಿ, ಬಟ್ ಆಂಗ್ಯುಲರ್ ಪ್ಯಾರಾಮೀಟರ್ ಅಲ್ಲಿ ಹೇಳ್ತೀನಿ. V equal to u plus at ಬದಲು omega equal to omega naught plus alpha t. ಥೀಟಾ ಈಕ್ವಲ್ ಟು ಒಮೆಗಾ ನಾಟ್ ಟಿ ಪ್ಲಸ್ ಹಾಫ್ ಆಲ್ಫಾ ಟಿ ಸ್ಕ್ವೇರ್ ಯಾವುದಕ್ಕೆ ಅಂದ್ರೆ ಎಸ್ ಈಕ್ವಲ್ ಟು ಯು ಟಿ ಪ್ಲಸ್ ಹಾಫ್ ಎ ಟಿ ಸ್ಕ್ವೇರ್ಗೆ ಬರುತ್ತೆ. ವಿ ಸ್ಕ್ವೇರ್ ಈಕ್ವಲ್ ಟು ಯು ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2as ಇದೆಯಲ್ಲ, ಅದಕ್ಕೆ ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಈಕ್ವಲ್ ಟು ಒಮೆಗಾ ನಾಟ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ 2 ಆಲ್ಫಾ ಥೀಟಾ ಬರುತ್ತೆ. ಇದಿಷ್ಟು ಪ್ಯಾರಾಮೀಟರ್ನ ನಾನು ಮಾತಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ ದ ಡಿಸ್ಟೆನ್ಸಸ್ ಆರ್ ಮೆಜರ್ಡ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್? ಇಟ್ ಈಸ್ ದ ಪಾಯಿಂಟ್ ವೇರ್ ದ ಹೋಲ್ ಮಾಸ್ ಆಫ್ ದ ಬಾಡಿ ಸೀಮ್ಸ್ ಟು ಬಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್. ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿರುತ್ತೆ, ಅದನ್ನ ನಾನು ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಅಂತ ಕರಿತೀನಿ. ಹೌ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಪೊಸಿಷನ್ ಆಫ್ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಅಂದ್ರೆ ಜನರಲ್ ಇಕ್ವೇಶನ್ ಆರ್ position of center of mass is equal to two body system ಗಾದ್ರೆ m1r1 plus m2r2 divided by m1 plus m2. ಅದೇ ವೆಲಾಸಿಟಿ ಕೇಳಿದ್ರೆ ವೆಲಾಸಿಟಿ along center of mass is given by m1v1 plus m2v2 divided by m1 plus m2. Okay. ಈ ಈಕ್ವೇಶನ್ಸ್ ಆಫ್ ಮೋಷನ್ ಯೂಸ್ ಮಾಡೋದ್ರ ಜೊತೆಗೆ ಟಾರ್ಕ್ ಅಂತ ಕರಿತೀನಿ, ವಿಚ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ರೊಟೇಷನಲ್ ಎಫೆಕ್ಟ್ ಅಬ್ಸರ್ವ್ಡ್ ಇನ್ ಎ ಬಾಡಿ ವಿಚ್ ಈಸ್ ಆರ್ ಕ್ರಾಸ್ ಎಫ್ ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ರೊಟೇಷನಲ್ ಎಫೆಕ್ಟ್ ಆರ್ ಇಂಟು ಎಫ್ ಇಂಟು ಸೈನ್ ಥೀಟಾ ಇಂಟು ಎನ್ ಕ್ಯಾಪ್ ಅಂತ ಕರಿತೀವಿ. ಇದೆಲ್ಲ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಯಾಕೆ ಅಂತ ಕೇಳಿದ್ರೆ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಂತ ಫ್ಯಾಕ್ಟರ್ ಬರುತ್ತೆ ವಿಚ್ ಈಸ್ ಗಿವನ್ ಬೈ ಐ ಎಂ ಇಂಟು ಆರ್ ಸ್ಕ್ವೇರ್, where m is the mass of the body and r is the radius alla perpendicular distance from the axis of rotation to the point under consideration ನಾನು r ಅಂತ ಕರಿತೀನಿ. ಅದೇ ಸೆಂಟರ್ ಆಫ್ ಮಾಸ್ ಅಲ್ಲಿ ತಿರುಗ್ತಾ ಇದೆ ಅಂದ್ರೆ then it will be mk square ಅಂತ ಕರಿತೀನಿ, where k is known as radius of gyration. Radius of gyration and m is the mass across the center of mass ಆಗುತ್ತೆ. Now ಎರಡು ಮೂರು ಬಾಡಿ ಇತ್ತು, how to calculate the total moment of inertia ಅಂದ್ರೆ moment of inertia is sum of the individual values i1 plus i2 plus i3 ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇಲ್ಲಿ ಎರಡು ಥಿಯರಮ್ಗಳನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಪ್ಯಾರಲಲ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್ ಅಂತ ಕರಿತೀನಿ, which is called parallel axis theorem. Parallel axis theorem ಏನ್ ಹೇಳುತ್ತೆ ಅಂದ್ರೆ ಟೋಟಲ್ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಬೌಟ್ an axis is equal to sum of the moment of inertia across the center of mass axis plus mr square ಅಂತ ಹೇಳುತ್ತೆ. ಅದೇ ಇನ್ನೊಂದಿದೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್ ಅಂತ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಕ್ಸಿಸ್ ಥಿಯರಮ್ ಹೇಳೋದೇನು ಅಂದ್ರೆ ಝೆಡ್ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಕಂಡುಹಿಡಿಬೇಕು ಅಂದ್ರೆ ಸಮ್ ಆಫ್ ದ ಇಂಡಿವಿಜುವಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಮೊಮೆಂಟ್ಸ್ ಆಫ್ ಇನರ್ಷಿಯಾ ವಿಲ್ ಗಿವ್ ಯು ದ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಅಕ್ರಾಸ್ ದ ಅದರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಕ್ಸಿಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗಾದ್ರೆ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಏನಾದ್ರು ವ್ಯಾಲ್ಯೂಸ್ ಇದೆಯಾ ಅಂದ್ರೆ ಎಸ್, ವಿ ಹ್ಯಾವ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂಸ್. ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆಫ್ ಎ ಸ್ಪಿಯರ್ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಇದು ಬೇಕಾಗುತ್ತೆ. ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆಫ್ ಎ ಸ್ಪಿಯರ್ ಈಸ್ 2/5 mr square. Moment of inertia of a ring across its diameter equal to mr square by 2. Moment of inertia of a rod will be equal to ml square by 12. Moment of inertia of a hollow sphere ಅಂದ್ರೆ ಬಾಲ್ ತರ ಆಗುತ್ತೆ, ಒಳಗಡೆ ಹಾಲೋ ಇದ್ರೆ ಇಟ್ ಈಸ್ 2/3 mr ಸ್ಕ್ವೇರ್. ಇದೆಲ್ಲ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಈಕ್ವೇಶನ್ಸ್ ನಾನು ಉಪಯೋಗಿಸುವಂಥದ್ದು. ಓಕೆ, ರೈಟ್. ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಇಲ್ಲಿ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಅಂತ ಮಾಡ್ತೀವಿ. ಹೇಗೆ ನಾವು ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಕನ್ಸರ್ವೇಷನ್ ಮಾಡಿದ್ವೋ ಅದೇ ತರ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಕನ್ಸರ್ವೇಷನ್ ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬಹುದು. ಎಲ್ ಟೋಟಲ್ ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್ ಇಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಐ ಅಂಡ್ ಒಮೆಗಾ ಅಂತ ಹೇಳ್ತೀನಿ. ಸೊ ಐ ಜಾಸ್ತಿ ಆದ್ರೆ ಒಮೆಗಾ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಒಮೆಗಾ ಜಾಸ್ತಿ ಆದ್ರೆ ಐ ಕಮ್ಮಿ ಆಗುತ್ತೆ, such that the product I omega will be always maintained constant. Now kinetic energy of a body is given by half I omega square. Rotating body is given by half I omega square ಅಂತ ಹೇಳ್ತೀನಿ. ಇಲ್ಲಿ I is the moment of inertia, omega is the angular velocity. If a body is undergoing rolling motion, roll ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ what is the total kinetic energy ಅಂತ ಕೇಳಿದ್ರೆ total kinetic energy is the sum of translational kinetic energy plus rotational kinetic energy. Translational kinetic energy is half mv square, rotational kinetic energy is half I omega square. So half mv square, half I omega square will be the translational and rotational kinetic energy na ನಾನು ಯೂಸ್ ಮಾಡ್ಕೊತೀನಿ. So these are the basic formulas related to system of particles and rotational motion. I think we can go to question number 24. 24ನೇ question ಗೆ ಹೋಗೋಣಂತೆ. Look into this one. A merry-go-round has a radius of 5 meters, completes 1 revolution in 4 seconds. Acceleration ಕೇಳಿದರೆ. So A equal to R omega square. A equal to R omega square. ನೋಡಿ R ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 5 ಮೀಟರ್. But what is omega? Omega is 2n pi by t ಅಲ್ವಾ? ಹೆಂಗ್ ಬಂತು? Omega equal to theta by t. So theta is 2n pi divided by t. So 5 into square ಇದೆ 5 into 2 into it completes ಎಷ್ಟು ಹೇಳಿದರೆ 1 revolution into pi in how many second? In 2 second ಹೇಳಿದ್ರೆ 4 second ಹೇಳಿದ್ದಾರೆ. So whole square ಆಯ್ತು. ಇಲ್ಲೇ 2 1 times 2 twice ಆಯ್ತು. ಏನ್ ಬಂತು 5 by 4 pi square ಆಯ್ತು. So acceleration will be 1.25 pi square. Option C has the answer for it. Right. Next one. 25th ನೋಡಿ. 25th one. Moment of inertia of a flywheel of mass 20 kg. Moment of inertia of a flywheel of mass 20 kg about its own axis is 500 kg meter square. Then its radius of gyration ಕೇಳಿದರೆ. Simple ಆಗಿದೆ. I equal to m into k square. So k equal to root I divided by m ಆಗುತ್ತೆ. ಹೌದಾ? ಸೊ ರೂಟ್ ಐ ಡಿವೈಡೆಡ್ ಬೈ ಎಂ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಸೊ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದ ವ್ಯಾಲ್ಯೂ ಐ ಕೊಟ್ಟಿದ್ದಾರೆ ಎಷ್ಟಿದೆ ಐ ಇಸ್ ಗಿವನ್ ಟು ಬಿ 500 ಡಿವೈಡೆಡ್ ಬೈ ಇದು ಮಾಸ್ ಎಷ್ಟಿದೆ 20 ಇದೆ. ಸೊ ದಿಸ್ ಗೋಸ್ ಯು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ರೂಟ್ 25 ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 5 ಮೀಟರ್. ಕರೆಕ್ಟ್. Twenty-sixth. A fan makes 600 revolutions per minute. Angular velocity ಕೇಳಿದರೆ simple ಇದು. Angular velocity is given by 2n pi divided by t ಅಲ್ವಾ? So 2n pi n number of rotations ಕೊಟ್ಟಿದ್ದಾರೆ 600 ಅಂತ 2 into 600 into pi divided by 1 minute ಅಂತ ಕೇಳಿದರೆ 60 seconds ಆಗುತ್ತೆ. So this will go to 10 which is equal to 20 pi ಆಯಿತು. 27th ನೋಡಿ. A body released down an inclined plane. A body is released down an inclined plane describes a circle of radius 0.2 meter in the vertical plane on reaching the bottom. Vertical plane on reaching the bottom. Bottom ಹೋದಾಗ ವರ್ಟಿಕಲ್ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆಯಂತೆ. ಹಾಗಾದ್ರೆ ಏನ್ ಕೇಳಿದರೆ ದ ಮಿನಿಮಮ್ ಹೈಟ್ ಆಫ್ ದ ಪ್ಲೇನ್ ಕೇಳಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಮಿನಿಮಮ್ ಹೈಟ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ ನೋಡಿ. ದಿಸ್ ಈಸ್ ಎ ಪ್ಲೇನ್ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣಂತೆ. ಓಕೆ, ಸೊ ಎ ಬಾಡಿ ಈಸ್ ರಿಲೀಸ್ಡ್ ಡೌನ್ ಇನ್ ಇನ್ಕ್ಲೈನ್ ಪ್ಲೇನ್. ಇಲ್ಲಿಂದ ಇನ್ಕ್ಲೈನ್ ಪ್ಲೇನ್ ಅಲ್ಲಿ ರಿಲೀಸ್ ಮಾಡಿದ್ರು. ರಿಲೀಸ್ ಮಾಡಿದ ತಕ್ಷಣ ಕೆಳಗೆ ಬಂದ ಮೇಲೆ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಎ ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್. ಹಿಂಗೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ ಆಫ್ ರೇಡಿಯಸ್ 0.2 ಮೀಟರ್. ಸೊ ರೇಡಿಯಸ್ ಎಷ್ಟಾಗ್ತಿದೆ? 0.2 ಮೀಟರ್ಗೆ ಹೋಗ್ತಾ ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ ವಾಟ್ ಈಸ್ ದ ಹೈಟ್ ಫ್ರಮ್ ವಿಚ್ ಐ ನೀಡ್ ಟು ಡ್ರಾಪ್ ದ ಬಾಡಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಹೈಟ್ ಎಷ್ಟು ಹೈಟ್ ಅಲ್ಲಿ ಇರಬೇಕು ಅಂತ ಕೇಳಿದ್ದಾರೆ ಅಲ್ವಾ? ನೋಡ್ಕೊಳ್ಳಿ, ಇದು ಫಸ್ಟ್ ಇನಿಷಿಯಲಿ ಬಾಡಿ ರೆಸ್ಟ್ ಅಲ್ಲಿದೆ. ರೆಸ್ಟ್ ಅಲ್ಲಿದೆ ಅಂದ್ರೆ ಎಂಥದ್ದಾಯ್ತು? ರೆಸ್ಟ್ ಅಲ್ಲಿದೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಅಂಡರ್ಸ್ಟುಡ್ ಆಬ್ವಿಯಸ್ಲಿ ಇಟ್ ಈಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ mgh ಆಯ್ತು. ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಎಂಥ ಎನರ್ಜಿ ಆಯ್ತು? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ½ mv² ಆಯ್ತು. ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಮತ್ತು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ಐ ಹ್ಯಾವ್ gh ಈಕ್ವಲ್ ಟು ಅಥವಾ 2gh ಈಕ್ವಲ್ ಟು v². ಇಲ್ಲಿ ಎಂಥ ಬಾಡಿ ಅಂತ ಹೇಳಿರೋದು? ಎಂಥ ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್ ಅಂತ ಹೇಳಿರೋದ್ರಿಂದ ದ ವೆಲಾಸಿಟಿ ಫಾರ್ ವರ್ಟಿಕಲ್ ಸರ್ಕಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ v ಈಕ್ವಲ್ ಟು ರೂಟ್ ಆಫ್ 5 into r into g. ರೂಟ್ ಆಫ್ 5rg is for vertical circle. So 2gh ಈಕ್ವಲ್ ಟು ರೂಟ್ ಆಫ್ 5rg ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಸ್ಕ್ವೇರ್ ರೂಟ್ ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. 2gh ಈಕ್ವಲ್ ಟು ಏನಾಯ್ತು? 5rg ಆಯ್ತು ಅಷ್ಟೇ. 2gh ಈಕ್ವಲ್ ಟು 5rg. g ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. h ಬೇಕು. 5r ಡಿವೈಡೆಡ್ ಬೈ 2. 5 ಇಂಟು ರೇಡಿಯಸ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 0.2 ಮೀಟರ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಡಿವೈಡೆಡ್ ಬೈ 2. ಇದು 0.1 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. Height will be 0.5 meter. So 0.5 meter is there in option B. Right? Look into the next one. Ha. 28th ಗೆ ಹೋಗೋಣ. one. Moment of inertia of a sphere of mass 10 kg, radius 0.2 meter, about diameter is 0.4 kg meter square. About any tangent. Tangent ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ it is parallel axis theorem ಆಗುತ್ತೆ. I equal to IC plus mr square. ಸೊ IC ಎಷ್ಟು? 0.4 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಮಾಸ್ ಎಷ್ಟು? 10 kg. ರೇಡಿಯಸ್ 0.2 whole square. So it is equal to 0.4 plus 10 into 0.04 ಆಗುತ್ತೆ. 0.4 plus 0.4 ಆಗುತ್ತೆ, which is equal to 0.8 kg meter square ಆಗುತ್ತೆ. ಆಪ್ಷನ್ ಯಾವ್ದ್ರಲ್ಲಿದೆ? 0.8 is in option B. ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ನೆಕ್ಸ್ಟ್ ಒನ್ ನೋಡಿ. Look into the next one. 29th one ನೋಡಿ. Important problem of 29th. 3 masses M1, M2, M3 are located at the vertices of an equilateral triangle of length A. Moment of inertia of the system about an axis along the altitude of the triangle passing through M1. M1 ಮುಖಾಂತರ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ. Look here. Equilateral triangle M1, M2, M3 are the 3 masses which are situated. They have asked you to calculate the moment of inertia across the axis passing through M1. ಹಿಂಗೆ M1 ಮುಖಾಂತರ ಪಾಸ್ ಆಗಿ ಹಿಂಗೆ ರೊಟೇಟ್ ಆಗ್ತಾ ಇದೆ. This distance AA ಅಂತ ಹೇಳಿದರೆ what will be the other distance? ನೋಡಿ ಈ ಕಡೆದು ಏನಾಗುತ್ತೆ? It will be A/2 ಆಗಲ್ವಾ? A/2 here, A/2 here, correct? So total moment of inertia is sum of the moment of inertia I1 plus I2 plus I3 ಆಯ್ತು. I1 plus I2 plus I3 ಏನಾಯ್ತು ನೋಡಿ. I1 is M1 R1 square, M2 R2 square plus M3 R3 square. So I equal to M1. R1 is 0 because it is passing through the axis itself. M2, R2 is A/2 whole square. R3 is A/2 whole square. So ಏನಾಯ್ತು? M2 into A square by 4 plus M3 into A square by 4 ಆಯ್ತು. ಏನು ಕಾಮನ್ ಸಿಗುತ್ತೆ? ಕಾಮನ್ ವಿಲ್ ಬಿ A square by 4 ಕಾಮನ್ ಸಿಕ್ಕರೆ M2 plus M3 A square divided by 4 ಆಯ್ತು. M2 plus M3 A square by 4 is in option C. Option C ಅಲ್ಲಿ ಇದೆ. Right? Okay, look into the next one. Thirtieth one ನೋಡಿ. 30th. A cord is wound around the circumference of a wheel of radius r. The axis of the wheel is horizontal. Moment of inertia is I. A weight mg falls from one end at the attached to the end of the cord. A weight falls from rest. After falling through a distance h, angular velocity of the wheel will be ಅಂತ ಕೇಳಿದರೆ one of the important problem ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬಂದಿದ್ದಂತಹದ್ದೇ ಇದು ನೋಡಿ. A wheel is there of radius r. ಇದರ ಸುತ್ತ ಐ ಆಮ್ ವೈಂಡಿಂಗ್ ಎ ಕಾರ್ಡ್, ಒಂದು ದಾರ ಸುತ್ತುತ್ತಾ ಇದ್ದೀನಿ ಅಂತ ಹೇಳಿದರೆ. ಸೊ ಐ ಆಮ್ ವೈಂಡಿಂಗ್ ದ ಕಾರ್ಡ್ ಲೈಕ್ ದಿಸ್. ಎ ಕಾರ್ಡ್ ಈಸ್ ವೌಂಡ್ ಅರೌಂಡ್ ದ ಸರ್ಕಂಫರೆನ್ಸ್ ಆಫ್ ದ ವೀಲ್. ಇದಕ್ಕೆ ಇನ್ನೊಂದು ಈಗ ಒಂದು ಪ್ಯಾನ್ ಹಾಕಿದ್ದೀನಿ, ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ದೀನಿ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣಂತೆ. ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಎಂಥ ಎನರ್ಜಿ? ಇಟ್ ಈಸ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಯು. ಹೌದಾ? ಈಗ ಇದಕ್ಕೊಂದು ಮಾಸ್ ಅಟ್ಯಾಚ್ ಮಾಡಿದೆ. ಇಫ್ ಐ ಅಟ್ಯಾಚ್ ಅ ಮಾಸ್, ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಟು ಫಾಲ್ ಡೌನ್. ಇಟ್ ಟ್ರಾವೆಲ್ಸ್ ಎ ಹೈಟ್ ಹೆಚ್ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ, ಅವ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಕೆಳಗೆ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ಆ ವೀಲು ತಿರ್ಗಕ್ ಶುರುವಾಗುತ್ತಲ್ವಾ, ದ ವೀಲ್ ಆಲ್ಸೋ ಸ್ಟಾರ್ಟ್ಸ್ ಟು ರೊಟೇಟ್. ಸೊ ಇಟ್ ಈಸ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಒಂದು ರೊಟೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ, ಇನ್ನೊಂದು ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಏನ್ ಕೇಳಿದರೆ, ಹಾಗಾದ್ರೆ ಆಫ್ಟರ್ ಇಟ್ ಹ್ಯಾಡ್ ಫಾಲ್ ಥ್ರೂ ಎ ಹೈಟ್, ವಾಟ್ ಈಸ್ ದ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಆಫ್ ದ ವೀಲ್, ವೀಲಿನ ಆಂಗ್ಯುಲರ್ ವೆಲಾಸಿಟಿ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ನೋಡ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ಬರ್ಕೊಳ್ಳಿರಂತೆ. ಎಂ ಜಿ ಹೆಚ್ rotational kinetic energy half I omega square, translational kinetic energy half m v square. 2 ಕಾಮನ್ ತೆಗೆದುಬಿಟ್ಟು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ. 2mgh ಈಕ್ವಲ್ ಟು I omega square ಪ್ಲಸ್ mr ಸ್ಕ್ವೇರ್ ಆಯ್ತು. ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲೂ ನಂಗೆ ಆರ್ ರೇಡಿಯಸ್, ಸಾರಿ ಎಂ ವಿ ಸ್ಕ್ವೇರ್, ಇಟ್ ಈಸ್ ನಾಟ್ ಎಂ ಆರ್ ಸ್ಕ್ವೇರ್, ಇಟ್ ಈಸ್ ಎಂ ವಿ ಸ್ಕ್ವೇರ್ ವೆಲಾಸಿಟಿ. m into v square. So, but I know that v equal to r omega, substitute ಮಾಡ್ತೀನಿ, I omega square plus m into r omega whole square ಆಗುತ್ತೆ, which is equal to I omega square plus mr square omega square. Omega square ಕಾಮನ್ ತೆಗಿತೀನಿ, I plus mr square ಆಯ್ತು, ಈಕ್ವಲ್ ಟು ಏನಿದೆ 2mgh. ನನಗೆ ಒಮೆಗಾ ಸ್ಕ್ವೇರ್ ಈಕ್ವಲ್ ಟು 2mgh ಡಿವೈಡೆಡ್ ಬೈ I ಪ್ಲಸ್ mr ಸ್ಕ್ವೇರ್ ಆಯ್ತು. ಒಮೆಗಾ ಬೇಕಾಗಿದೆ, ಇಟ್ ಈಸ್ ರೂಟ್ ಆಫ್ 2mgh ಡಿವೈಡೆಡ್ ಬೈ I plus mr square is the angular velocity. So which is there in option C ಅಲ್ಲಿ ಇದೆ ನೋಡಿ. One of the important question usually ಕೇಳ್ತಾ ಇರ್ತಾನೆ ಇದನ್ನ. Okay. ರೈಟ್, ನೋಡ್ಕೊಳ್ಳಿ ಇದನ್ನ, ಇಂಪಾರ್ಟೆಂಟ್ ಒನ್ನು. Next one. Next one, 31st. Total kinetic energy of a sphere of mass m rolling with velocity v is. ನೋಡಿ, ರೋಲ್ ಆಗ್ತಿದೆ ಸ್ಪಿಯರ್, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಈಕ್ವಲ್ ಟು ಸಮ್ ಆಫ್ ರೊಟೇಷನಲ್ ಎನರ್ಜಿ ಪ್ಲಸ್ ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಸೊ ರೊಟೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಮತ್ತು ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಸೇರಿದ್ರೆ ಟೋಟಲ್ ಎನರ್ಜಿ ಸಿಗುತ್ತೆ. ಸೊ ಟೋಟಲ್ ಎನರ್ಜಿ ಸಿಗ್ತಾ ಇದೆ ಅಂದಾಗ, ವಾಟ್ ಈಸ್ ದ ರೊಟೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ? ಹಾಫ್ I omega ಸ್ಕ್ವೇರ್. ವಾಟ್ ಈಸ್ ದ ನಾರ್ಮಲ್ ಕೈನೆಟಿಕ್ ಟ್ರಾನ್ಸ್ಲೇಷನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ? ಹಾಫ್ m v ಸ್ಕ್ವೇರ್ ಅಲ್ವಾ? ಹಳೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನನಗೆ ಎಂ ವಿ ಇರಲಿಲ್ಲ, ಸೊ ವಿ ಈಕ್ವಲ್ ಟು ಆರ್ ಒಮೆಗಾ ಬರ್ದೆ. ಬಟ್ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನೋಡಿ, we have kinetic energy in terms of mass and velocity. Mass and velocity ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಹಾಫ್ ಹಾಗೆ ಬರೀತೀನಿ. Moment of inertia of a sphere, which is a standard value 2/5 mr square. Omega equal to v by r whole square plus half mv square. ನೋಡಿ, 2 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ಉಳಿಯೋದೇನು ನೋಡಿ, 1/5 mr square into v square by r square plus half mv square ಆಗುತ್ತೆ. ಇನ್ನೇನು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ? r square ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. ಯು ಹ್ಯಾವ್ 1/5 mv square plus 1/2 mv square ಆಯ್ತು. So mv square common tegedre 1 by 5 plus 1 by 2. So kinetic energy will be equal to mv square ಇಲ್ಲಿ 10 LCM ಆಯ್ತು, which is 5 plus 2. So total kinetic energy will be 7 by 10 mv square. The standard formulation ಇದು. ಯಾವುದರಲ್ಲಿದೆ? Option A has the answer for this question. ನೋಡ್ಕೊಳ್ಳಿ. So these were the problems related to kinematics 2 ಗೆ ಸಂಬಂಧಪಟ್ಟಂತಹ problems. Now chemistry class will be there. ಒಂದು 2 ನಿಮಿಷ chemistry class ಶುರುವಾಗುತ್ತೆ. Thank you, students. We'll meet in the next class. Now you'll be having chemistry class.
ಮ್ಯೂಟ್ ಮಾಡಲಾ?
ಮ್ಯೂಟ್ ಮಾಡಿ. ಹೋಗ್ಬಿಡಿ ಸರ್. ಹೋಗಿ ಸರ್. ಅಲ್ಲಿ ನೋಡ್ಕೋತೀನಿ ನಾನು.
ಅದನ್ನು ನೋಟ್ ಕಳಿಸ್ಬಿಟ್ಟು ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ. ಮೇಡಮ್ ಕಳಿಸಿದ್ದಾರೆ, ನೋಡ್ಬೋದು. ಆಡಿಯೋ ವೆರಿ ಗುಡ್ ಆಫ್ಟರ್ನೂನ್ ಟು ಈಚ್ ಒನ್.
ನಾವು ಅಲ್ಲಿ ನೋಡ್ತೀವಿ ಸರ್.
Today we'll take up states of matter, solids and surface chemistry. So all these are related to each other. We will discuss what we are going to come across in the case of the states of matter, solids and surface chemistry. So as we all know, matter is nothing but anything that occupies the space and which can able to have the mass that can be defined as the matter. So it is of 3 types that we all know. So solids, liquids and gases. So on the basis of the intermolecular force of attraction, we can able to categorize them into solids, liquids and gases. So the intermolecular attraction of the atoms or the molecules is so strong and they are compactly arranged. At that time they will have the definite shape and as the high mass, so they are considered to be the solids. So in the case of the liquid, what happens? The intermolecular force of attraction that will be loosely arranged so that they can able to acquire the shape of the container. So they doesn't have any definite shape. In the case of gaseous molecules or gases, the of the atoms, they are freely in the area that we are going to have. So what can able to bind these molecules that we are going to see in this particular case? So in the case of the polar substances, in the case of the polar molecules, remember it's very important. So molecules. So next, in the case of the polar as well as the non-polar molecules, along with the polar molecules and non-polar molecules, polar as well as non-polar molecules. So this is also the another force that can able to bind the molecules in this particular case, that is called as dipole induced dipole force. Dipole induced dipole force. So this particular area, so they are going to ask you to write the questions in this area. Next we are going to have the hydrogen bond. The hydrogen bond in this particular case, so where we can able to see the hydrogen bond force that we are going to see in the case of the molecules which are highly electronegative. So normally what happens whenever the nitrogen combines with the hydrogen, then we are going to have the oxygen with hydrogen. So in these cases, so highly electronegative element that they are going to be get binded along with the hydrogen. At that time, there will be a hydrogen bond formation that we can able to see in this particular case. So next, we are going to have thermal energy. What is thermal energy that we will have to see in this particular case? Thermal energy andre ಏನು? Thermal energy ಅಂತಂದ್ರೆ, so in this particular case what happens, the body arising from the motion of its atom, the energy that is going to arise from the body due to its motion, so it is directly proportional to the temperature. It is directly proportional to the temperature, that is called as the thermal energy that we are going to come across in this particular case. So normally, now we are coming across the gaseous state. As we all know, the gaseous states, so the gases, the characteristics of the gases that we will have to understand in this particular case. Gases can be highly compressible in nature. So they are easily compressible in nature. They can able to exert pressures in all the directions. They can able to exert the pressure in all the directions. So there is a weak intermolecular force of attraction between the gaseous molecules that we are going to come across in this particular case. As the density is concerned, density is very low in the case of the gaseous substances. So when compared to the solids and liquids, the density is very low in this particular case. So these cannot able to have a definite shape and the volume, but we can able to fix the volume, but as it is, they are free in the surrounding. Therefore, we cannot able to say it is a, so they doesn't have no definite shape and the volume in the case of the gaseous molecule. Next, normally the gas laws that we have come across. So you have studied the gas laws. Boyle's law. At constant temperature, the pressure of the fixed amount of gas is inversely proportional to the volume, that you know. Then the Charles law, when the pressure remaining constant, the volume of the fixed mass of the gas is directly proportional to the absolute temperature that we are going to come across. So Gay-Lussac's law that we are going to say, at constant volume. In this case, you will have to see the constant volume, the constant pressure, and the constant temperature that we are going to see in this particular case. In the Gay-Lussac's law, at constant volume, the pressure of a fixed amount of gas varies directly with that of the temperature. That is P1 by T1 is equal to P2 by V2 that we are going to express in this particular case. Then we are going to come across the Avogadro's law in this particular case. So Avogadro's law and similar conditions of temperature and pressure, equal volume of gases contain equal number of molecules. That is V is equal to N, we will say the thing. So then we are going to have the ideal gas equation. As you all know, the ideal gas equation that we are going to come across, PV is equal to nRT. So this is the ideal gas equation that we are going to come across in this particular case. So when we are going to combine the gas laws, what happens? So when we write the combined gas law, P1 V1 by P2, I mean T1 is equal to P2 V2 by T2. This is the combined gas law equation that we are going to have. So for the density of the gas is concerned. So when we say the density, so that is D is equal to Pm by RT that we are going to say. So in this case, the M is nothing but the molar mass of the substance or molar mass of the gas that we are going to have. So these terminologies you will have to remember in this particular case. So next we can able to have Dalton's law of partial pressure that we are going to see in this particular case. The total pressure exerted by the mixture of non-reactive gases is equal to the sum of the partial pressure of the individual gas. So that we are going to consider it as, so P total is equal to P1 plus P2 plus P3 so on. So we are going to have in this particular case. So at constant, remember, so at constant temperature and volume. So this is very important that we will have to have in this particular case. Next, kinetic gas equation that we are going to come across in this particular case. The kinetic gas equation that we are going to mention. So PV is equal to 1 by 3 MnC square. So this is the kinetic gas equation. So M is nothing but the mass of the substance. So that is N is the number of moles. C is the root mean square velocity or root mean square speed of the gas that we are going to have in this particular case. So V is the volume that you know. Next, real gases. So the real gases which obeys the all the gas laws only at low pressure and high temperature conditions, they are called as real gases. Ideal gases can able to obey all the gas laws in various conditions that we are going to come across. Next, they are going to give you the van der Waals equations that we are going to come across in this particular case. So van der Waals equation, as you all know, so for in this particular case, for n mole of gas that we are going to come across, P plus An square by V square. So into we are going to have V minus NV. So into RTR, that is equal to RT that we are going to have. This is for n mole of gas that we are going to have in this particular case. So normally what happens, the compressibility factor that we will have to understand in this particular case, the compressibility factor that we are going to say as Z. So in this particular case, it can be given as Z is equal to PV. So pressure and volume divided by nRT. So this is the compressibility factor. So if the Z is equal to 1 for the ideal gas, Z is not equal to 1 in the case of the real gases. So over all the gases, when they are going to have the positive deviation, we are going to see the Z value is greater than 1. So when the gases with the negative deviations, that we are going to have the value in the case of the, so Z lesser than 1 in this particular case that we are allowed to have in this particular case. So liquid state, So in this case, the vapor pressure that we are going to come across, the vapor pressure, it is nothing but the pressure exerted by the vapor. So present in the equilibrium with a liquid in a closed vessel at the particular temperature. This is very important. This is very important. Then boiling point. So the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric or external pressure, that is considered to be the boiling point of the liquid. So next, surface tension. So it is the force that acting per unit length perpendicular to the line drawn on the surface of the liquid. So in this particular case, the SI unit in the case of the surface tension we are going to use as Newton meter. So that we are going to have the unit, that is the SI unit for the surface tension that we are going to come across. Next, viscosity. What is viscosity in this particular case? It is nothing but a measure of resistance to flow, which arises due to the internal fraction between the layers of the fluid, and they are going to slip fast one another while liquid flows. This is called as the viscosity that we are going to come across in this particular case. This we can able to represent in this particular case as the force. So that is eta A. So that we are going to have du by dz. So this is the equation that we are going to use to calculate the viscosity of the liquid. In this case, so du by dz is the viscosity gradient that we are going to have. So in this particular case, no change in the velocity that we are going to see in the case of the distance. So eta is the coefficient of the viscosity in this particular case. So F is the force required to maintain the flow of a liquid in this particular case. So that we are going to, A is the area that is in contact. That is what we are going to have in this particular case. Next, in the case of the solid, as we have discussed in this particular case, so the force of attraction, the interionic force, either the molecular force that we are going to have, or the covalent force. So on the basis of this one, we can be able to categorize the solids into various categories. So we have studied this particular one, ionic solids that we are going to come across in this particular case. Then molecular solids that we are going to have in this particular case. Molecular solids. So next we are going to have the metallic solids, then hydrogen bonded metallic solids. So hydrogen bonded. So the hydrogen bonded solids that we are going to have in this particular case. So in this case, these two can be considered togetherly. In the molecular solid, we can able to have the polar molecular and non-polar molecular solids. Then instead of this one, we can able to have another category in this particular case is the covalent solids. Covalent solids. So these two we can able to take together. No problem in it. So in this case, these are also called as the network solids, as we have come across in this particular case. So in this case, ionic force or the electrostatic force of attraction. So the covalent bond in this particular case, the hydrogen bond that can be able to see in this particular case. So normally in the case of the metallic solids, what happens? So the metallic solids in this particular case, we are going to have. So these are usually occupied, the positive ions surrounding which we are going to have the negatively charged ions that they are going to be present in the case of the metallic ions. Remember, the outer side of this metallic arrangement, the electrons are normally loosely arranged, therefore they are going to be very good conductors of the electricity in this particular case. As we all know, so the crystal lattice that you have come across in your theory. So the crystal lattice, what we are going to see in this particular case, it is a regular three-dimensional arrangement of the constituent particles in a crystal is called as the crystal lattice. The point in which they are going to be get arranged, that is called as the lattice point that we are going to come across in this particular case. So then the unit cell that we are going to come across in this particular case, a smallest portion of a crystal lattice, which is when required in the different direction, we can able to generate entire lattice structure, that is called as the unit cell that we are going to have. So as we all know, it is comprises of 6 parameters. So that is, so we are going to have alpha, beta and the gamma, 3 angles and 3 directions that we can able to say it is 3 edges. Totally 6 parameters that we are going to come across in this particular case. The very important thing that we should remember in this particular case, what we will have to remember in this particular case, the unit cells. So the simple cubes, we are going to come across simple cubes. So remember friends, in this particular area you are going to come across. So how we are going to calculate the contribution of the atoms per unit cell that we are going to have. So at corners we can able to calculate like this. See, you should remember this calculation so that it will be easier for you. So 8 into 1 by 8, that is equal to 8 that we are, that is what we are going to have in this particular case. Then the earth faces, it is visible now, earth faces. So there is 0 phase that we are going to have. So the total number of unit cell, so the total number of unit cell that we are going to come across is 1 in this particular case. So this is the number that you will have to remember. Next we will have to have the BCC in this particular case. So in this case, this is at corners, it is almost same, that is 8 into 1 by 8 that we are going to have. So at faces it is 0 only. So in the case of the center that we are going to have 1. So therefore, so this is total 1 plus 1, that is equal to 2. 2. In this case it is 1 only that we are going to have. So in the face centered cube, see, this is very important. On the basis of this one that they are going to ask you to calculate the centers, all these things. So in this particular case, 8 into 1 by 8. So that is equal to 1 that we are going to have. So then 6 face that we are going to have. 6 into 1 by 2 that we are going to have in this particular case. So normally at faces, so in this particular case, this is, so in this case in center we are going to have 0. The total that we are going to have in this particular case is 1 plus 3 is equal to 4 in this particular case. This you should remember in this particular case. Another important thing that we should remember in this area, so in majority cases that they are going to ask you to calculate the edge length in this particular case. So our packing fraction that we are going to have in this particular case, when z is equal to 1, remember, we'll see in this particular area, and z is equal to 4 and z is equal to 2. In these conditions, how we are going to calculate, what are all the different, so that we are going to formula to calculate this particular case. So in this case we are going to have d is equal to a, the density in this particular case, that a is the edge length. So that is 2r. R is equal to that we are going to have a by 2 in this particular case. This expression you will have to remember. In this particular case, T is equal to 2R. So that is equal to that we are going to have in this particular case a by root 2. This can also be calculated. R is equal to, so if at all you will have to calculate the radius, at that time you will have to use a by 2 root 2. So these are all the different expressions that we will have to use to calculate whether they are going to ask the density of the solids or edge length or the radius that they are going to ask. In this particular case, you will have to remember these formulas. So in this case, when the z is equal to 2 at that time, d is equal to 2r. d is equal to 2r that we are going to have in this particular case. That is equal to root 3a by we are going to have 2. So r is equal to, so if at all you will have to calculate the radius. So at that time that is equal to root 3a by 4. Root 3a by 4, this one. So these are the expressions that we are going to have in this particular case. Next we are going to have, so these are the formulas that we will have to remember to calculate the various edge length, density and also the radius of the crystal structure that we are going to have. Now another important question that will be appearing in this particular area is the calculation of the tetrahedral void and the octahedral void. Normally we are going to see. Friends, remember voids are nothing but the empty spaces. So these are triangular in shape. Normally we will say they are triangular in shape. So they are going to surrounded by, in the case of tetrahedral voids, they are going to be get surrounded by 4 spheres. So normally in CCP we are going to have the, in CCP tetrahedral voids are located on the body diagonals, means 2 on each side. 2 on each side. Remember this, you will have to remember. So because on the basis of this one, majority times question have been appeared. So then in the case of octahedral voids, so in this case they are usually surrounded by 6 spheres. So the triangular void which is usually surrounded by 6 spheres in this particular case. In the CCP, the octahedral voids are located at the body center and the edge center. At the body center and the edge center. So normally what happens? So if the n is the number of packed spheres, then the number of octahedral void generated is equal to 1. So normally if the n is the number of close packed sphere in this particular case, so in this case the total number of octahedral voids generated is called as n. The total number of tetrahedral void generated is called as 2n. This you will have to remember. So normally the another question that is there in the case of the FAMC and also so AFMC, there are many times that they have asked this particular questions. The radius in the case of the tetrahedral void, remember the value, the radius of tetrahedral void in this particular case. So this value you should remember, that is 0.225 R. So the same in the case of the octahedral void. In this particular case, we are going to have, so octahedral void. So we are going to have the value that is, in this particular case, 0.414 R. This is the value that you should remember in this particular case, where R is the radius of the sphere that we are going to come across in this particular case. Normally, the radius ratio. So in this particular area also there is a question. So that they are going to ask the radius ratio and the coordination number. I will tell you, because there are different types of question can be asked from this area. That is the reason why you will have to see this particular thing, the radius ratio. So what is the radius ratio and the coordination number that we are going to come across in this particular case? If you know these two, you can able to calculate the thing. In this particular case, 0.1552 So the radius ratio, if it is 0.225, so at that time, the coordination number in this particular case, it is almost 3. Remember, on the basis of the coordination number, you can able to calculate the structural arrangement of the thing. So next, this is 0.2252, 0.414. 0.414. In this particular case, so the coordination number of the crystal is 4 in this particular case, that you will have to remember. So 0.4142, the radius ratio, if it is 0.732. So the coordination number of the crystal in this particular case, so is 6, the coordination number. So if it is 0.732 up to 1, so the coordination number that we are going to have, so that is 8. That is 8. So as we all know, we are going to have the calculations of involving the unit cell dimension. So the unit cell dimension calculations, as you all know, so in theory classes you have calculated the density of a crystal and also you have calculated the edge length of the crystal. So remember, we are going to have in this particular case, so that is, we say rho, it is nothing but a density of the crystal that we are going to have. So that is z into m divided by, that we are going to have a cube into Na. So this is the formula that we are going to have. So into 10 to the raise minus 30 gram per cm cube or gram cm cube. So that is what we are going to have. So as you all know, imperfections that will be there in the case of the solids. So any departure or any vacant area that we are going to see the arrangement of the crystal, either the positively charged or negatively charged or the molecules, so that we are going to say as imperfections in the case of the thing, or they are considered as defects in the case of the solids. So normally what happens in this particular case? So that is deficit or departure from the perfectly ordered arrangement. So of the constituent structure of the crystal is called as the imperfection or the defect, we will say. Normally we are going to come across point defect and the line defects, as you all know. So the type of point defect, we are going to have stoichiometric defect. It is also, we are going to see in this particular case what happens. So these defects, they do not disturb stoichiometry of the solids. These are also called as intrinsic or thermodynamic defects. You should remember these terms in this particular case. In the case of non-ionic solids, vacancy defect can be seen. In this particular case, so the vacancy can be created in the case of the lattice point. So this can able to decrease the density. The vacancy defect can able to decrease the density. Then we are going to have the interstitial defect. So this is also in the case of the non-metallic, non-ionic solids that we are going to have. In this particular case, so atoms or molecule that can able to occupy the interstitial space. So a interstitial space where we can able to see the molecules in this particular case. So these can able to increase as the density of the solids or the crystal that we are going to have. In the case of ionic crystal or ionic solids, we are going to come across the Frenkel and Schottky defect that we are going to have in this particular case. So in this particular case, so the smaller ion, normally we will say cation, that will be missing in the case of the lattice site, that is normal site, and it enters into the interstitial site in this particular case. So in this particular case, the density do not changes that we are going to have in this particular case. Then in the case of this Schottky defect, what happens? Equal numbers of equal number of, so cations and anions are missing in this particular case. So normally they are almost replaced by a similar size of atoms, different atoms in this particular case. So these can able to decrease the density of the. So then we are going to have the impurity defect and metal excess defect that we are going to have in this particular case. So that you will have to remember. As far as the surface chemistry is concerned, so this is also related to this chapter only. So surface chemistry is concerned that we are going to come across. So it deals with the phenomena that occurs on the surfaces, or we can able to say it is interfaces in between the phases that we say. So normally what happens in this particular case? The accumulation of the molecules on the surface of any substance is considered to be the adsorption. See, there is a lot of difference between the adsorption and the absorption that we are going to have. So this absorption is a total phenomenon. So this is a total phenomenon. So this is surface phenomenon with that we are going to see. This is surface. So only any one surface the molecules can able to come and adhere or come and settles on the surface of the thing in this particular case. In this case, adsorption, it is surface phenomenon. So absorption is a total phenomenon that we are going to come across in this particular case. In the surface chemistry, we come across adsorbate and the adsorbent. The substance come and adhere, that is called as adsorbate. The substance on which the adsorbate settles, it's called as the adsorbent that we are going to have in this particular case. So there are various causes that we are going to have in this particular case. So the force between the adsorbent and the adsorbate molecule that we are going to see on the basis of this one. So we can able to treat two types of adsorption, that is physisorption, physical adsorption, chemisorption, that is chemical adsorption in this particular case. So in this particular case, we are going to come across physical adsorption is due to the weak van der Waals force of attraction. Chemical adsorption is due to the chemical bond formation, remember. So physical adsorption is not specific, whereas chemical adsorption is highly specific in nature. Physical adsorption is reversible, whereas chemical adsorption is irreversible in nature. So physical adsorption, it depends on the nature of the gas. So more easily liquefiable in this particular case. So in this case, it is also depend upon in the chemical adsorption also it is depend upon the nature of the gas. So whereas gas react with the adsorbent, so the chemisorption means chemical bond formation in this particular case. So low temperature is favorable for adsorption in the case of the physical adsorption. So in the case of chemical adsorption, high temperature is favorable for the chemical adsorption in this particular case. So activation energy does not require in the case of the physical adsorption. So high activation energy is necessary for the chemical adsorption in this particular case that we are going to have. So Freundlich adsorption isotherm curve that we are going to come across in this particular case, that is x by m is equal to k p power 1 by n, that is n is greater than 1 in this particular case, log m by x is equal to log k plus 1 by n log p. So on the basis of this one, we are going to calculate the Freundlich adsorption isotherms. So remember, factor affecting the adsorption of the gases in this particular case that we are going to see. So normally in the nature of gas being adsorbed, that is very important. So the nature and the surface area of the adsorbent, if it is greater, so we can able to see the maximum amount of molecules can be adsorbed on the surface of the adsorbent molecule. So next, pressure. At constant pressure, adsorption increases with the increase in pressure at constant temperature. Remember? So adsorption increases with the increase in pressure. temperature. So adsorption is a exothermic phenomenon. Remember, friends. So when we apply the Lee Chatelier principle, so when we increase the temperature, adsorption decreases. So when we apply the Lee Chatelier principle, so when we increase the temperature, it decreases. So next we are going to have catalysis. Catalysis is nothing but the substances which can able to increase the speed of reaction or velocity of the reaction. So, or they decrease the speed of reactions. They are called as the catalyst. So, the reaction that follows is called as catalysis. Catalysis means reaction. So, the substance that takes part to increase or decrease the speed or velocity of a reaction is called as the catalyst that we are going to come across in this particular case. We are going to come across broadly two types of catalyst, homogeneous catalyst, or reactions when we are going to consider homogeneous catalysis, heterogeneous catalysis. When you write homogeneous catalysis, no need to write the reaction. Catalysis itself indicates that it is a reaction. So homogeneous, all the reactant product and the catalyst are in the same state, either the solids or liquids or gaseous form. Hetero means different. The reactant and the product and the catalyst, they are in different phase or different state. So they are considered as the heterogeneous catalyst in this particular case. The important features that we'll have to remember in the case of the catalysis reaction is the activity of the catalyst. So the activity of the catalyst can able to increase the reaction in this particular case. So it can able to increase the speed of reactions. Next, selectivity. That is also very important. Selection of a catalyst that can able to change the product when you use the same reactant also. That is the reason why. So catalyst plays a dominant role. While selecting the catalyst, we can able to change the products. So by using the same reactant, if we change the temperature, pressure condition and catalytic conditions, we can able to change the product in this particular case. So normally we are going to have enzyme catalysis reactions. Enzymes are nothing but the biocatalyst, proteins that they are going to be get involved in this particular case. So these are highly efficient. So they are highly specific in nature. So they are very active in this particular case. Normally these reactions, they are going to occur between the pH of 5 to 7 pH range. So this question, it was appeared in the case of the KCET. So the pH range is between 5 to 7. During this particular pH, the enzyme reactions normally taking place. So the temperature being 298 to 310 Kelvin. So that is the normal temperature conditions in which the biocatalyst or the proteins or the enzymes that they are going to be take part in the chemical reactions that we are going to have in this particular case. Next, we have the colloids. Colloids are nothing but the heterogeneous system. In this particular case, there are so many questions that they are going to be have, in which one substance is called as dispersion phase. The another substance is called as the dispersion medium in this particular case. So normally what happens? So the substance can able to move on the another substance in this particular case. So that is called as the dispersion medium. So the range of diameter in this particular case, the molecules can vary from 1 and 1000 nanometer in this particular case. We are going to have the dispersed phase and dispersed medium and the type of colloids that we are going to see in this particular case. See, friends, the dispersed phase and the dispersed medium that we are going to have in this particular case, then the type of colloids that will be formed. Type of colloids that will be formed. This you will have to remember, because in majority cases there will be a question on this one for 1 mark. So both are in solid conditions. Remember, friends, both are in solid. We are going to say it is solid salts. They are considered as solid souls that we are going to have. So one is solid, other one is liquid. In this particular case, we are going to say it is an ordinary soul that we are going to have in this particular case. So solid and a gas in this particular case. Solid and a gas in this particular case. This is called as the aerosol that we are going to have in this particular case. Next, liquid and solid that we are going to have in this particular case. So the liquid and solid, we are going to have the gels. So next we are going to have liquid and liquids. So liquid and liquid, we are going to have the emulsions. We are going to have the emulsion mixture in this particular case. So emulsion mixture that we are going to have in this particular case, liquid and gas. See, when we are going to have the liquid and gas in this particular case, we are going to have the aerosols that we are going to have. So aerosol. Then lastly, we are going to have gas and solids, and also the gas in liquids. So for gas and solids that we are going to have solid sols. So in this particular case, lastly we are going to have the gas in liquid, that is called as the foam that we are going to have. So as we all know, so you have studied lyophilic and lipophobic. Then the classification of the colloidal particles that we are going to have in this particular case as a macromolecular and micromolecular and multimolecular colloids that we are going to have. In this particular case, we are going to have the preparation of colloids can be carried out by a chemical method and also by electrical disintegration method, that is called as the Bredig-Arc method that you have studied in your theory classes. So by peptidization method, we can able to prepare these colloids. So by using a specific peptidizing agent, we can able to prepare this particular one. Next, purification of these colloids can be carried out by dialysis process. So that is ordinary dialysis, electrodialysis, and also we are going to have in this particular case, so ultrafiltration method that we are going to see in this particular case. So as the properties are concerned, friends, you have studied the colligative properties, the Tyndall effect, Brownian movement, and the charge carried by the colloidal particles. So these can be separated by the electrophoresis methods. So that we are going to come across in this particular case. So applications that you can able to study on your own. So we will discuss the important aspects in this particular case. What are all the questions that we are going to see? Normally what happens in this particular case? The kinetic theory. I'll take up the questions now. The kinetic theory of gases predicts the total kinetic energy of the gaseous assembly. Depends on the first one. So pressure of the gas. Next, temperature of the gas, volume of the gas, pressure, volume and temperature of the gas. Remember, the kinetic theory of the gases predicts the total kinetic energy on the basis of the temperature of the gas. On the basis of the temperature of the gas. So option B is the correct answer in this particular case. Remember, according to kinetic theory of gases, the energy per mole of a gas is equal to 1.5 RT. So B RT, 0.5 RT, last we have 2.5 RT. Remember friends, in the case of this one we are going to have KE is equal to, kinetic energy is equal to 3 by 2 RT. Therefore, the answer is 1.5 RT. The answer is 1.5 RT, that is option A. That is option A that we are going to have in this particular case. Next, the third question that we are going to come across. partially potential and partially, vibrational energy of the molecule, we will say. So it is partially potential and partially kinetic, only potential, only kinetic, none of the above. Remember, the vibration of the molecule, it mainly depends on the potential energy of the molecule as well as the kinetic energy of the molecules. Therefore, this is option A is the correct answer. It is not only by the vibration or potential energy, or it is not only due to the energy due to the movement. Remember, it is partially potential and partially kinetic. So normally what happens in this particular case? If the gas is expanded at constant temperature, so if the gas is expanded at constant temperature, what happens in this particular case? The pressure increases, the kinetic energy increases, the kinetic energy of the molecules remains same, the number of molecules of the gas increases. So at constant temperature, remember, kinetic energy of the molecules will remain same. At constant temperature, the kinetic energy of the molecule will remain same. Therefore, you can able to take up the option B as the correct answer. Option B as the correct answer in this particular case. Remember, friends, the fifth question I am taking in this particular case. So, in this particular case, in the equation PV is equal to nRT, which one cannot be numerical value of R? Which one cannot be numerical value of R? Remember option A, 8.31 into 10 raised power 7 erg per Kelvin per mole. So 8.31 into 10 raised power 7 dyne centimeter per Kelvin per mole. So see, 8.31 joules per Kelvin per mole, 8.31 atmosphere per Kelvin per mole. In this particular case, all these, so they are considered to be the SI units. This is the other unit that we are going to have, that is 8.31 atmospheric per Kelvin per mole. That is option D. Option D that we are going to have in this particular case. Next, rate of diffusion of a gas is directly proportional to its density, directly proportional to its molecular mass, directly proportional to square root of its molecular mass, inversely proportional to the square root of its molecular mass. Remember, friends, the kinetic energy, rate of diffusion, it is mainly depend on. So it is rate of diffusion is proportional to root 1 by molecular mass. Root 1 by molecular mass means inversely proportional to the square root of its molecular mass. This is according to Graham's law of diffusion, friends. Remember. This is according to Graham's law of diffusion. So option D is the correct answer for this one. Next, we can able to take up a bottle of ammonia and a bottle of dihydrogen chloride connected through a long tube are opened simultaneously at ends. The white ammonium chloride ring first formed will be at the center of the tube, near the hydrogen chloride bottle, near the ammonia bottle. Throughout the length of the tube, rate of diffusion is proportional to root 1 by molecular mass of the Remember, friends, it is usually depend on the basis of rate of diffusion is proportional to root 1 by molecular mass. But in this case, So molecular mass of HCl is greater than the molecular mass of ammonia. Molecular mass of HCl is greater than the molecular mass of ammonia. Therefore, the white ammonium chloride ring appears near the hydrogen chloride bottle. Near the hydrogen chloride bottle. Option B. Because the molecular mass of HCl is greater than that of the molecular mass of ammonia. Therefore, the white ammonium chloride ring appears near the HCl bottle. Next, the eighth one that we are going to come across in this particular case. Which of the following indicates the value of the gas constant R? 1.987 calorie per degree per mole, 8.3 calorie per degree per mole, 0.821 liter per degree per mole, 1.987 joules per degree per mole. Normally, we are going to calculate on the basis of the calorie per degree per mole. That is the unit in which we are going to calculate. Therefore, so remaining all these three, they are other than SI units. They are other than SI units. So option A is the correct answer in this particular case. Option A is the correct answer in this particular case. Next, the van der Waals constant A for the gases oxygen, nitrogen, ammonia and methane are 1.3, 1.390, 4.170, 2.253 liters. This is liter square A atmosphere. Please correct this one. So that is liter square. So A atmospheric. So per mole this one. That is, I mean mole per liter this one. So that is inverse to. You will have to write like this in this particular case. So remember friends, respectively, the gas which can be most easily liquefiable: oxygen, nitrogen, ammonia, methane. Remember friends, in this particular case, A, it is directly related to the force of attraction. A is directly related to the force of attraction. Hence, greater the volume of A, more will be the liquefying nature of the gas. Greater the volume of A, more will be the liquefying nature of the gas. Therefore, what is the I value that has been given in your question that can be easily liquefied? Which means we are going to have ammonia, it is 4.170. Therefore, option C is the correct answer in this particular case. Greater the value of A. So such gases can be easily liquefiable. So next, the 10th one that we are going to have. Which of the following pairs will diffuse at the same rate through a porous plug? So as we know, we have discussed in the previous questions, the rate of diffusion is proportional to root 1 by molecular mass. So it is almost equal in this particular case. We have the paired compounds in this particular case: carbon monoxide, nitrogen dioxide, nitrogen dioxide, carbon dioxide. So ammonia, phosphine, nitric oxide, ethane in this particular case. So in this case, you can able to take up in this particular case. When we take the average of these three, in this case, so the nitric oxide, remember friends, the nitric oxide is equal to 30.01. So then the C2H6, ethane, it is 30.07 in this particular case. So if you carry out the value in this particular case, that is 1 by 30.01, that is equal to 0.333. So if you take this one also, it is 30.07. it is almost equal to 0.03325. So these two are similar. Therefore, you can able to take the pair option D as the correct one. Option D as the correct one. So next we will take up the question number 11. So the packing efficiency of two-dimensional square unit cell shown below. So option A 39.27%, 68.02%, 71.05%, 78.54%. See, in the two-dimensional packing, what we are going to have? So packing fraction that we are going to have in this particular case like this. So please take up like this. Area that is equal to area occupied by circles within square divided by area of the square. Area of the square. So how we are going to take in this particular case? That is equal to 2 into pi r cube by a square. So in this particular case, we are going to have we can able to see like this. AC is equal to root 2 AB square plus BC square. So as per the figure, that is equal to root A square plus A square, that is equal to root 2A. So in this case, but AC, remember AC is equal to 4R. R is nothing but the radius of each sphere. So therefore, you can able to take up. So root 2A is equal to 4R. R you can able to define like this. A is equal to 4 by root 2. A is equal to 4 by root 2. So R, isn't it? R you can able to take up 2 into root 2. So packing efficiency. So when you apply this one in the equation, so you can able to apply to this equation. So I'll take up this one. Remember friends, what we are going to have in this particular case, this is equal to 2 into pi r cube divided by, isn't it? So 2 into root 2 r whole square, that is equal to pi by 4, or you can able to say 3143 divided by 4. So this is equal to 0.785. Therefore, you can able to take up the value, that is 78.5. If you make it to 100, you will get the 78.5. So in this case, option D is the correct answer. Next, we can able to take up. Next question, that is question number 12. So in this case, perovskite, a mineral of titanium, is found to contain the atoms at the corners, oxygen atom at the face center, and titanium atoms at the center of the cube. The oxidation number of titanium in the mineral is +2, +3, +4. So see, remember friends, you can able to calculate like this. Calcium atom per unit cell, you know, calcium atom per unit cell is 8 into 1 by 8 is equal to 1, that we are going to have. Oxygen atoms, remember, oxygen atoms per unit cell is equal to 6 into 1 by 2, that is equal to 3. So ends. So straight. Titanium you will allow to take up, isn't it? So titanium. So atom per unit cell is equal to 1. Therefore, the formula ಏನಾಗ್ತದೆ? So in this particular case, formula is CaPiO3 ಆಗ್ತದೆ. This is the formula of the compound. So you will have to calculate the oxidation number of the titanium now. Therefore, what we are going to have, calcium is plus 2 into oxygen that we are going to have. So you take up the titanium as X into oxygen, 3 into minus 2, this is equal to 0, and X is equal to plus 4, this one. Oxidation state